International Management Consultancy. I hope you all are with me, and still some students are joining with us. So let them join with us, and at the same time I will have a small conversation with you all regarding actually who we are, IMC Institute. And I'm really glad to see you all that you have joined to Lean Six Sigma Yellow Belt free session with us. And again, warm welcome to sit for this session. And let me talk about IMC Institute Abu Dhabi and who we are. International Management Consultancy is a leading global provider of learning and instruction for professional qualification, including Six Sigma. We are providing PMP and SCM by connecting all the students all over the world, and we are helping to achieve their dreams, achieve their goals, and we are giving our full of support to grab as much as they can from our side, and we are giving sessions and everything, all the support which they have to get from our side to study by themselves. And what we do actually not only about Lean Six Sigma, whatever the training they want from our side, we are providing them unlimited training and consulting. So from our side, what we exactly do, we are providing them unlimited training till they're satisfied with our services. And at the same time, I would like to talk about what we offer. Actually, in IMC Institute Abu Dhabi, we are proud to say we are in quality wise, in service wise, we are providing them a good service. And what we offer them, we are offering them Lean Six Sigma certification. Let me tell you about Lean Six Sigma Green Belt, Black Belt, and Master Black Belt. At the same time, we are offering them supply chain management and Project Management Professional, PMP. Let me talk about our accreditations. IMC Institute Abu Dhabi, we are so proud to say that we are approved by CPD London and CSSC, Council of Six Sigma Certification USA, IQF, International Quality Federation USA. And we are approved by UAE Activate, which is United Emirates Arab global body, government body, which is giving us the much more strength to show how much we are strong global wise. And we are having students around the world to sit for our sessions and to grab as much as they can to study maximum the way they can, because we are giving our full up support. And I'm proud to introduce our team to you all. Our training director, Ms. Madhavi Singh, and our general manager, Mr. Mohammed Sajjad, and our quality head, Ms. Deepa, and our product head, Mr. Shashank, and our associate director, Mr. Farhan. At the same time, when we talk about our team, it's not a team that everyone is having to work. This is the team which is giving their hard work, the support, and the strength and the knowledge to everyone who they deserve to be a person, like to who they wants to be in the future. So this team is always helping to others to achieve their goals, study hard, and to be flexible with us. Whatever the requirements, we never ignore. This team is always supportive, and they are giving good services to each and everyone without any fear.
To you people. Hi, this is Divine here, the trainer for Lean Six Sigma Yellow Belt.
Yes, we can hear.
Okay, hi everyone. And what about the screen? Can you see the screen?
Not yet. Can personally
No,
see anything.
I can see.
Okay, so in my screen, I've opened a word pad. I just wanted you guys to confirm if you can see that, please.
No, I can't. I can't see.
No, we can.
Just a moment.
There is a black screen.
Can you see it now? There you go.
Yes.
No,
Yes, sir. Now it is
Yes.
okay.
I can't see you.
Okay, not me. I'm not. The camera is off. Can you see the screen? Is what I'm asking.
Yes, we can see the screen.
Yes, we can.
I can't see the
We can
screen.
see the
Yeah.
screen already.
Okay, all right, all right.
Yes,
I'll
I
be
can
watching.
see that.
Yes, just give me a minute. Just give me a minute. Okay, guys, the first and foremost thing is I would request all of you to just mute your mic. And in case if there is a question, you can ask me directly, okay? So prior to that, just keep your mics on mute, all of you.
Okay, I can see the screen.
Okay, yeah, thank you, thank you. Okay, just don't annotate anything on there for the time being, okay?
Okay. Okay.
And also, guys, just keep yourself in mute so that it doesn't, I mean, the background noise will start coming off. So that is the only reason I'm requesting you people to just keep them mics on mute for the time being. Hanan, I can see you. Could you kindly keep your mic on mute, please?
Okay, I'm trying to mute it.
Yep, yep. Okay. So if my voice is very much okay now, and you can see my screen, so without wasting any more time, we'll just start off the session. I can see that we have more than 60 participants in for the Lean Six Sigma Yellow Belt training. And yes, so to start with, my name is Deban. I'm a Lean Six Sigma accredited trainer from IASSC. And I can still hear some background noise, guys. Please, if you don't mind, if you can kindly mute yourself. It is for whole of the class, please. Okay, great. So this is the thing that we're going to study today, okay? Lean Six Sigma, yellow belt. It is not. Okay, for some reason. Okay, just a moment. Okay, now you can turn on your mic and let me know if you guys have got any kind of an experience in working on a Lean Six Sigma project before, prior to this. Has anyone got any idea as to what Lean is or Six Sigma is all about?
Divine, can I say something?
Yes, please. Yes.
I have got 5 years of oil and gas project experience as project engineer. As I know about only the Six Sigma, I don't know about the Lean Six Sigma, but what I have the understanding of Lean Six Sigma, that it is basically a quality improvement method of any industry.
Hi, I think the host is on mute. Can you unmute yourself because we can't hear you?
On the system?
Yes, now you are audible.
Yeah, we can
Yes,
hear
sir.
you.
Now
Hello?
it is audible.
We can hear you now. Earlier, we can't.
Yeah, we can hear you, sir.
Okay. So everything is perfect, right? I can start with the thing.
Kindly zoom out your screen.
Yeah,
It is too large.
Hello.
but I think there's someone who is not on mute, so there's a lot of interruption.
Okay, guys. I just got a call saying that you people were not able to hear me, but I'm not sure as to why that had happened. But again, let me just recap on the things that I was just talking to you guys about. Lean is about removal of the waste, and the second line is Lean is going to help us in simplifying the process. So I'm just detailing out for you as to which are the steps that we have to know. I mean, which are the things that we have to know when it comes to lean. So let me write down first, and then I'll speak to you about all the points here.
Diban, sorry to disturb you. Can you please zoom the screen?
Okay. So lean is about removal of the waste. Okay. So first of all, when I'm talking about the waste, you have to know about muda. Now, what is muda, and how many types of mudas are there is something we will be discussing now. And apart from mudas, we also need to know about mura and muri. Okay, so just follow along. Here, I'm going to take you to a
Diban, your screen is too large. We can't see. Kindly zoom out your screen. It's too large.
just look at this particular thing, okay? So we can speak on this one for next half an hour or 1 hour. But as they say that a picture speaks 1,000 words, and this is what we are going to do now. So as I told you, it is about 3 things. Okay, muda, let me just take this off for the timing so that you people don't get confused. Muda, mura, and muri. So these are the 3 things that you must know. Okay, what are these things? So now just have a look at this picture, the one that is there in front of you. Okay, muda is something which is about the waste. Okay, mura defines unevenness, and muri is something which says that it is overburdened. Now, let me let you know for the fact that as a Lean Six Sigma guy, when it comes to lean, the first approach that you should be having in your mind is about removal of the waste and simplifying the process. And this is what I have written here, simplifying the process. Okay. So now the 3 things are muda. So let's start with the muda first. Okay. Let's start with the muri thing. What is muri? Just follow along. It is very easy. These are the basic concepts that you should be knowing, okay? So muri is about overburden. So in the work life, sometimes what happens is one person would have to deal with a lot of work. And all of a sudden, there would be few people who you would find in the process who are like kind of free. Like out of the stipulated 8 hours of working that they have, they would be working only for maybe 3 hours or 4 hours. And then there will be some few people who would be slogging it out. Okay, this is what you need to understand. And this is the whole definition about muri. So all the things, all the names that you see here, these are Japanese words, okay? And let me let you know one thing. These are Japanese terms. A lot has been contributed by Japan to where Lean Six Sigma stands today. A lot of it. So you should be knowing for the fact that all the terms that you see here, mura, mura, muri, this is all coming from Japan. Muri is something which is about the overburdening. As I told you, there would be a colleague of yours who would be kind of working only for 4 hours, and for the rest of the 4 hours, they would be free. And then again, you might be seeing some of the candidates who would be like slogging it out, maybe even have to go for extension of their work hours. Like if 8 hours is the stipulated time that they have to work, they might have to extend it by maybe 1 hour or so. And this is something which has to be avoided. Okay. So before we go to the basics of lean, these are a few things that you should be knowing about. So first thing is muri. And how do you identify it? Just look at the picture here. So you have 6 blocks, okay? And all the 6 blocks were placed in one single truck. So this is something which is a classic example of understanding muri, which is overburden.
Are you showing something? I can see.
Now let's look into mura. What is mura now? Mura is something which is talking to you about unevenness. Okay. So, just a moment. Unevenness. So it is just talking to you about, like, you remember we had 6 blocks in there, right? So see, in one of the blocks there, I mean, in one of the trucks, you have 4 of those blocks, and in another truck, you have only 2 of it. So this is something which is which is showing us the fact that there is a fluctuation, there is a variation, okay? And most of all, the way that you would want to identify this is the fact that it is having unevenness. So they could have done something like this, okay? But what they chose to do is, in one of the trucks, you see there are 4 blocks, and in another truck, there is only 2. So this is
Excuse
something which
me,
is representing
can
the
Sorry to
uneven.
interrupt you, but we cannot
Now
see
comes the
anything.
best part, guys, that you guys should be aware of. This is Muda. Muda is something which is waste.
the speaker cannot
You
listen
see,
us?
there are 3 trucks which is carrying 2 blocks.
I'm
Okay,
just not able
each
to
of it
hear
is
us.
carrying only 2 blocks. This is something which is a problem. Guys, is there any problem?
Yeah, we are not able to
We
see.
cannot see your
Yes,
screen.
everyone kindly mute yourself if.
Sorry to interrupt you, but we are not able to see. Are you showing us something? We are only able to see things which you are writing.
Guys, I see that there are a few of you who actually are not able to listen to what I'm trying to speak here.
There are some interruption there.
I'm showing you a picture as well as I'm writing in here. Okay, thanks that you can hear me, but what about the picture, the one that I'm trying to show you? Okay, guys,
We cannot see
please
any
don't
of the
annotate
picture.
here.
Can you please see the chats, because we can't hear you, we can see your screen. I don't know if you're able to hear us.
Can you see the picture now?
Yeah, now we can see the
Can
picture.
all,
Yes,
can all see the
yes, we
picture
can see
now?
the picture
Now we
already.
can.
Okay, fine. So let's not involve ourselves and do anything else. Okay, there was a technical problem, I guess, because of which you were not able to see as to what was happening in here. Again, guys, just to repeat, I was just talking to you about the first 3 things that we need to know as a Lean Six Sigma guy. This is about the Muri, which is about, like, just come here and see. So this is about a truck which has been loaded with 6 of the blocks. And we know that this is something which is overburdening. And I was just talking to you about an example wherein you would see certain candidates in your office itself who would be, after 4 hours of work, they would be completely free. All right. They do not have much in their plate. But at the same time, you would also tend to find certain candidates who would be, like, overburdened with their job. Okay. They might even need to slog out even after the working hours. That is something which is called in Japanese as muri. Okay, so muri is nothing but overburdening of anything. Okay, so this is something which you must know when anyone talks to you about muri. Now, slowly you'll be able to relate to all the terms in just a while. Let me just finish it first. Then comes mura. Now, what is mura? Mura is something which is talking to you about the unevenness. So see how many blocks we have here? We have 6 blocks. But for those 6 blocks, what is happening here is we have 2 trucks, and on those 2 trucks, in one of the trucks we have placed 4 blocks. Of one of the trucks we have placed 4 blocks, and in the other truck we have just 2. Okay, this is of course a problem. This is something which is causing a fluctuation, a variation of some sort. Okay, and this in just for the understanding, you must know that this is something which is related to unevenness, and this has to be avoided. So this is talking to you about mura. So the first 2 things are clear, muri and mura. Then comes Muda, guys. Muda is something which is about waste. Waste. And what is this? Let's just look into it first. So here you see we have 6 blocks, but at the same time they have employed 3 trucks in here. And those 3 trucks are taking 2 blocks at a time. Okay. And even you can see that there are empty spaces in between. And if this was well arranged, we would have done something like this, wherein you have no Muri, no Mura, or no Muta. So this is something which is showing a waste. Okay. So as a Lean Six Sigma guy, as I told you, we have to eliminate the waste. This is one of those points that we must remember. Okay. Eliminate the waste. And this is something that we have to do. So this is about the Muda, Mura, and Muri. So if you go to Google, guys, if you just go to Google anytime, you'll see that there are plenty of examples which will talk to you about the Muda, Mura, and Muri thing. Take for an example, let me just open this one for you. See, this is Muri, which is about the overburden. This is Mura, which is about the unevenness. This is Muda, which is just a waste of time. Like whatever they're trying to do is just a waste of time. So I'm just taking a help of Google, nothing else. This is something which is available to you people also. So I request you to kindly come into Google in case of further examples. And if you really want to know it better. Just for a moment, let me show you this as well, so that the concept stays in there with you completely. Where is that? Okay, I'm not finding it here, but you understood what I'm trying to say, right? So Muda, Mura, and Muri. Now, there is something about the Muda, okay? This is especially now we are talking about the Muda. So just a moment. Please don't annotate, guys. We would be now talking about the Muda. No, it doesn't have a full form. These are just the Japanese names. It doesn't have a full form of its own. It is just the names. Okay. And guys, this is something that you must avoid. Okay. Please don't annotate. Everyone out there. This actually takes off the concentration that we need to have in understanding the one that we are here for. Okay. We will be now talking about the Muda. Okay. So Muda, as we know, it is just a waste, okay, that we have to deal with. And you would want to remember Muda as Tim Woods. Now, what is this Tim Woods? Let me just show you again here. If you can see this, okay. T stands for transportation. So any waste that is happening because of the transportation issue, like the transportation is taking a longer time. The mode of transportation that is happening in any of the process, any of the organization is taking a lot of time. That would be considered as one of the waste. So it starts with transportation. Okay. And this is something that you must remember about the Muda, the first thing. Then comes inventory. Now, what is inventory? Now, every company would keep the raw materials in their inventory, correct? So as and when the time comes, it is not only about the raw material, even the finished goods are kept in inventory. So there's a lot of charge that a company incurs, okay, whenever they keep those things in the inventory. So this is a problem. So this of course is a problem. So how are we going to overcome this? See, the fact is every company would want to keep themselves at a good state, saying that in case if there is a request which is coming their way, okay, they would want to do, what they would want to do is they would want to deliver the goods or the products to the customer at the earliest. But inventory is also considered as a waste. I'll tell you why. Because once you keep a lot of products in the inventory, what happens is you need to also employ people to, I mean, a lot of people, say, suppose it is about edibles, okay, edible products. So what is happening here is you would be employing a lot of people to come and check as to if everything is properly placed or not. And there is, of course, always a fear of the rodents and the insects coming and doing a damage to your products. This is especially when it comes to having a edible products. Okay. Now, apart from it also, say suppose it's the company that you are a part of, okay, they are manufacturing AC or a TV or any electronic goods which is of a bigger size, maybe a TV, washing machine, or a AC. Now, in here, what is happening is it's an electronic product. Everything has to be checked. The place where it is kept, you must make sure that there is no leakage and all. So essentially, what I'm trying to say here is inventory, having a little inventory is always good. It is also, I mean, it is not only for the final product, it is also for the raw materials. But at the same time, if you're having a huge quantity of it, it becomes a problem for you, because that would be now considered as a waste. Because for you to safeguard the ones that you have kept as a inventory is going to, I mean, bring in extra cost. So what is the idea of a company? The idea of a company is to eliminate all the, eliminate all the unwanted costs, correct? So this is something which can be avoided if you know what I'm trying to say when it comes to inventory. And this is the next of 10 words. So for now that you are into Lean Six Sigma Yellow Belt, this is one thing that you must be knowing, all right? Because the first project that you would be handling, I suppose it is not going to be directly dealing with Six Sigma. First of all, you need to take those baby steps for the Lean, because Six Sigma is something which is all about the statistics. We'll come to that as well, but let's just complete this one. Put your focus in understanding what I'm trying to say. Yeah, the first one was transportation, the second is inventory, and the third is the motion. Motion is also considered to be a kind of waste. So I'll tell you how. Suppose the printer which is kept in the office, all right? So wherever you are, if the printer is kept in such a place, wherein for some people it's very nearby, all right? But for some of them, they have to walk a lot for them to reach towards the printer. This, of course, is a problem, right, guys? So make sure that the printer is placed in such a place which is easily, people can easily commute to it, because it is something which is of a daily need in an office environment. So all those small things, all those small changes that you see, it is just about a mindset, guys. If you have the right mindset of doing or bringing out change, then you'll definitely do it. But also, let me let you know that change is not very well accepted, okay? And if you guys have been working in the office environment, you guys must be knowing about the fact that change is not very well accepted. For any change that you bring, there will be backlashes. But the thing is, what this is our job, and this is for what the company would be paying us. We need to identify the waste, and then we need to eliminate it. For that matter, let me just talk to you about the process maps. You guys must be knowing about the process maps, right? So see, the process map or the work instruction or the standard operating procedures, all the things that you have in an office. So this is something which is not only going to help the existing employees, but it is also going to help the new hires. So what happens with the new hires? They will come, they will sit and speak with the people who are there, the tenured people. So they'll come for the first 15 days or 20 days, they'll try to learn as to what is happening in the process. But remember one thing, the person who's acting as a buddy to the new hire, even he has his work to be done. He or she has their work to be done. It becomes a certain problem, right? So he has to concentrate on his work, at the same time guide the new hire as to how the things are to be done. So what happens is here, this process mapping thing or the standard operating procedures or the work instructions, these are very, very immensely helpful for the new hires. Okay, so now let's just get back to this one, the motion thing. So motion, as I told you, motion is all about you having the, I mean, the motion should be very less. Okay, motion is also considered to be waste. So just take an example. I mean, think about the example which I have given you about having the printer placed and at the right place. Now, what is waiting, guys? Waiting is also something that you must be aware of. Okay, so we are waiting for the things. So what happens is, guys, initially people used to think that, okay, for explaining waiting thing, I have to talk to you about something else. Now, initially what used to happen was people used to think that waiting is all about like you uh, you're making someone wait. Like suppose you're working for there are three processes. Okay, process A, process B, and then you have process C. So what is happening in between us? The process A cannot start their work until and unless the process B is done with their work. And in the same manner, process B cannot start working as long as the process A is not completing their work. Sorry, this should be placed. Don't worry about the thing, okay? Just concentrate on what I'm saying. So process should be placed here, okay? So now initially what used to happen was we had only the concept of having an external customer. Who is an external customer? Anyone who is paying us the money for buying the product that we are selling out to them. But here comes Mr. Joseph Juran. Okay, I'm just going to type out his name. Joseph Juran. He was the person who actually coined the term of internal customer. So internal customer. So what he actually tried to say was, you have to treat the teams who are working along with you, I mean the next team itself, as a customer. So for process A, process B is a customer. For process C, process B is a customer. Just consider yourself to be working in process B. So who becomes the customer for you? Process C becomes the customer for you. So this is a concept which is coming from the fact that we need to consider our teammates or the next process of ours as a customer. Guys, please mute yourself, everyone. And this is something which is very much necessary. All right. So if we consider the next process to be what do you say, internal customer for us, then we would avoid this waiting. Okay, then we would understand the importance of them. Otherwise what happens is we keep the next process waiting. It is just about our job, but anyone who's working as a manager or the team lead, they have to know about this fact very well, that waiting is just a waste and we need to, of course, overcome it. Now, that was about the waiting thing. So transportation is clear, inventory is clear, motion is clear, waiting is clear. Now let's understand what is over processing. See, over processing and over production is something which you might think that it's one and the same. And to be honest, it is not much different also. So over processing is something like more than the one that is required. So the customer has asked for, the processing of the thing, okay? But you have gone ahead and did a lot more than what was expected. So this is something by which you would be able to understand what is over processing. Okay, the same thing. So comes the overproduction now. Overproduction, anyways, customer asked for 50 products. Okay, 50 products. What you did was you just went ahead and made 100 products. What is happening out here? There is a cost. There is a certain cost which is involved. Okay, for you to increase your production from 50 products to 100 products. This becomes a problem for everyone, guys, and of course for the company as a whole. So these things are something which has to be avoided. Then there are defects. Okay, there would be defects. Suppose, okay, now when I'm talking about the defect, I must also let you know for the fact that there is a difference between the defect and a defective. Okay, which is a greater concept as and when you come to the Lean Six Sigma green belt and the Lean Six Sigma black belt with us. This is something which you need to identify very well. And there are different charts which you need to know, which is like the P, NP charts, U chart, C chart. So this is talking to you about the attribute data. So I'll come to the attribute data and a continuous data right after this, because those are the basics that you must be doing. And guys, I'm requesting you to mute yourself, please. So defects. So let me just let you know about the defects first. So your mobile, okay, the mobile that you're using, just imagine that there is a problem with the sound. So what happens? It becomes a defect for you, right? For every, I mean, for the usage, it becomes a defect. Now the defect could also happen with what do you say? The defect could also happen with the screen, maybe. Okay. So when you have two defects, that is how you would be counting about how many defects are there. Okay. So when I'm talking about the defects and Tim Woods, just be there with me, because straight after this, I'm going to take you to the concept of the DPU, DPO, and DPMO. Okay. So defect is all about you having as to how many number of defects you have. But let me take this opportunity to speak to you about the defective part as well. What is defective? You having one defect or two defect doesn't matter. What matters is, and what matters for the defective is whether even if there is one defect in your mobile phone, the one that you're using, the example that we took, it becomes a defective piece, correct? So this is what you have to know. This is the basic difference between defects and defective. I am going to delete it for the timing so that you do not get confused with the ones that you should be dealing with. What Tim Woods, which is especially talking to you about the muta. Okay, so I'm not talking much about that for the timing. Just remember, defects can happen anywhere. Okay, so this is something which we have to avoid. And the final thing, which is skills. Now, talking about the skills, I have to mention that if suppose you're hiring a candidate, okay, this guy is very good with this. What do I say? Um, Data processing or something. Okay, this guy is very good with his data processing skills and all. And suddenly you would want to involve this guy into what do I say? A proper statistics thing, okay? One who's dealing with the statistics, the hypothesis tests and all, anything which whatever is required for you to become a statistician, a data scientist or something. This guy was doing his job, which was all about like data entry. And you suddenly pick this guy and you have put them into a data scientist position. What happens? This is a problem, right? This problem, even if it is not showing up at the very immediate, it is going to be a problem, and this is going to be definitely a problem in the long run. Because when a company hires you, there's a lot of money which is involved. The company hires you, provides you with the training, and all the comforts. I mean all the comforts in which you would. Guys, I'd request you to kindly mute yourself, please. So it just disturbs, okay, guys. So I'm just requesting you. It is just a matter of few more hours. So let's concentrate on it. So I have done it. I've done it. I've done it. Over processing, guys. Okay. Just a moment. You see this? Doing more work than necessary. This could be something like over processing. Okay. And doing work before it is needed could be overproduction. Defects, mistakes and error that needs to be reworked. So simple as that. But these things are something which you can directly go to Google and find out yourself. Okay. And that is the reason let's concentrate on all the other things as well. And remember, we haven't started speaking about the Six Sigma as well. So just concentrate as to what is happening. And yeah, I'm sure you'll be able to catch it. It is not a very tough thing. Then skills, as I was giving you an example. So while hiring a candidate, you need to first understand as to what is the requirement of the process or the organization or the project that you are hiring a person for. Hire your person correctly. Otherwise, it is going to backfire. Okay. This is something that I would want to let you know, you guys know about. Now you understand about this Lean Six Sigma projects and those huge projects which is saving millions and millions of dollars for the companies. So you as a Lean Six Sigma expert in times to come, maybe down the line, 1 month or 2 month. So what happens is you have to very much start concentrating on all those projects, starting with the lean. Understand the lean. Lean is not that tough. Lean is just a mindset, guys. Yes, of course, there are plenty of tools in leans, which I would share with you in just a while. But this is something that you must know about the lean thing is lean is something that we guys have been doing in our home since our childhood to make anything more efficient, to remove the waste, to simplify the process. This is something that we have been doing since our childhood in our home. See, our parents would have taught us to maybe just go and clean the dressing table. Just keep the things tidy in your wardrobe or something. Okay, or maybe keep the study table clean. Guys, how many times I have to let you know that we do not want anyone to annotate here. Please make sure you're not doing it. So, anyways, so all the things that I just told you about was about the lean thing. And please remember that. Gosh. I'm not able to rub it also. Please do not do such things. Here comes the Six Sigma, all right. So that we have now known as to which are the things that we must be knowing about. Here the things are about simplifying the process, eliminating the waste. And once you eliminate the waste, of course, there will be reduction in the cost and increase speed and efficiency. Once you deal with all this Tim Woods thing, it is going to help you in removing all the wastes. Guys, whosoever is done it, can they remove it, please? I'm not sure. I'm not able to do it from my side.
Sir, the host can do it.
Guys, Lean Six Sigma is not something which you should take lightly. All right. So everyone out there, I'm sure most of you are concentrating hard. This is something which is going to pay you more than $100,000 as a salary package. And this is the first step that you guys are taking. So yeah, thank you so much. So let's just concentrate on the thing because we do not have much time. You guys know it. Okay, so start with Six Sigma. As of now, we were just taking an overview of what is lean all about. Now we'll look into what the Six Sigma is going to do for us. Okay. So the first things first, Six Sigma is about eliminating the errors. Okay. Second thing is, guys, we can reduce the variation. And this is very important. This particular thing is very important, okay? Reducing the variation. The third thing is make system changes. Make system changes. And the fourth thing will be sustain the improvements that the improvement measures that you have taken. Okay. So now, lean is about the waste thing, simplifying the process, increasing the speed and efficiency. That is just a picture of lean that you would want to know. So when it comes to Six Sigma, guys, in Six Sigma, the main thing, as I've highlighted it here, it is about reducing the variation for the process to be effective and with improved quality. Okay. Lean and Six Sigma complement each other. Integration as Lean Six Sigma is the best strategy that can be followed for any of the company. Now, when it comes to me talking to you about reduction of the variation, there are two variations that you must be aware of. Okay, these are common cause. Sorry, let me just write it. Common cause variation and special cause variation. Now just concentrate on the one that I'll be talking to you about, okay? Now imagine your office starts at 9, okay? Your office starts at 9. Now, most often what happens is if it is about business process management or something, and if at all your company is providing a cab for you, then of course you don't need to worry. But at the same time, it cannot be always that you reach your office on time. And this is how you should. I'm now trying to talk to you about the common cause variation. Okay, so just follow along with me. So sometimes, just for an example, you would be sometimes reaching your office by 8:55. Sometimes you would be reaching your office by 9:05. Okay, no AM. I'm not writing the AM thing, but this is pretty much understood, right? In the mornings itself. It could be night also, who knows? So I did my jobs for nights, no issues with that. But just take an example for the morning thing here. Okay, so 9 o'clock is what the time that you are supposed to reach your office, and you reach office by 8:55 or 9:05. So see, sometimes you're early by 5 minutes, and sometimes you're late by 5 minutes. You'll get to know about the lean thing when we start talking about the tools. Okay, there are tools that you need to know for you to identify yourself completely with the lean thing. Let's not jump the gun. All right. There's a reason for everything. Okay, let me just concentrate. I'm not looking into this chat thing for the moment. Let me just concentrate in here. So this is about this thing wherein you have to reach your office by 9 o'clock, and sometimes you are late early by 5 minutes, and sometimes you are late by 5 minutes. So there is a gap of 5 minutes in there. So this happens to be, of course, considered as a common cause variation. It can happen everywhere. Remember, common cause variation is something, there is variation in each and everything in this world. Anything that you see around you would be having a variation, all right? And the ready product also the process wherever anything was happening is also about the variation thing itself, guys. So this is about the common cause variation. Now let me talk to you about the special cause variation. Suppose again 9 o'clock you have to reach your office. Okay. So sometimes what happens is you reach your office late. Say suppose you reach your office by 9:40. So what is happening in here? There is a specific problem for which you have reached your office 40 minutes late, correct? Those specific problems would be considered as a special cause. So for you reaching your office by 9:40, there could be an issue with the traffic that you had to face while going towards the office. On the route to your office, there was a huge traffic. This could be a problem. And this would fall under the ambit of a special cause variation. Now again, sometimes you might be reaching your office early on. So like this is 8:20. Suppose there is someone who's staying in your locality and he or she comes up to you saying that anyways, I'm going towards the direction of your office. So if you want to come, you can come along so that you can avoid the bus and the cab thing for today. And you say, yeah, okay, but this is pretty much early. But anyways, I'll come with you. So what happens is you reach office very early because you are now going in a bike or maybe a personal vehicle. So you reach the office on time. So this is something that you guys must be knowing about the special cause variation and the common cause variation. Okay. We as a Lean Six Sigma guy, our job would be to deal with the special cause variations. Okay. This is something that we must be dealing with. So, okay, let me just write a few things for you here. The variation can happen because of the manpower. It could happen because of, when I say manpower, I'm talking to you about the people, okay? It could happen because of the methods or the procedures that was followed in there, methods, procedures, or the training methods that were followed. The special cause variation, I mean, the total, okay. One thing I forgot to mention here, the all of it, when you take the special cause variation and the common cause variation together, this becomes the total cause variation. Okay, so coming back to this thing again, the variation is often due to the difference in manpower, methods, machines, measurement, material, or mother nature. When I say mother nature, it is just talking to you about the environment. Say suppose you're making something in an inside of what do you say, inside the factory, which wherein you need to have a certain temperature. If it exceeds, the products that you are making could have a problem. Okay, so sometimes it normally happens with the materials which are made for the building constructions and all right, those special cements and all right. So for that, this could be a problem, and hence this mother nature is also included in here. It could happen because of the measurement, the material that you're using, the machines that you're using, the methods or the procedures that are followed, the manpower, the people who are working there, and of course the mother nature, as I told you. This together constitutes, guys, this is known as 6M, which you will find a lot, which you'll get to see a lot in times to come. So this is again about Mr. Ishikawa from Japan, who actually formulated, who actually gave fishbone diagram. Okay, this fishbone diagram is something which is about the cause and effect relationship. Cause and effect relationship. Okay, so you guys must be aware of, if till date you are not, let me just show you this cause and effect thing. Let me type in fishbone diagram. See, I had to type that thing itself. So you see, this is just like a fishbone, all right? And all the things that I just mentioned you about, the measurement materials, This is personal. This is just one of those M's. Okay. Normally it is about this 6 M's. So in here, if I'm just writing 6M diagram, you see the same thing is going to come up. 6M. So just have a look at this. Machines, methods, materials, mother nature, manpower, measurement. So this is something which is just like a fishbone, and this is the effect. And for you to understand why the effects are, I mean, why if there is any effect, we need to identify the causes, and these 6 things happens to be the causes for you. Okay. And we would also sometimes use the 5 whys and all those things for understanding. So all those things we would just look into in just a minute. Let me just see what is there. Ishikawa, yes, of course, Ishikawa. So this is about the Ishikawa thing. Now, this is what I had mentioned here. I just missed your name, sorry. But Ishikawa is the one who actually gave. He was also from Japan. So as I told you, there's a lot of contribution which has happened from Japan for the cause of Lean Six Sigma. So what else we have to talk about? Okay. So having said that, guys, this is the initial thing that you should know about the Lean and the Six Sigma. What Lean does for us is about the waste thing that I've explained a lot as of now. And next comes you having to deal with the variations. So the total cost variations could be because of the common cost variation or the special cost variation, and this is something which has to be removed. Okay, this is what our job is going to be. Okay, so we are not only dealing with the Lean, we also have to deal with the Six Sigma thing. Now, what do I show you next? Okay, let me just talk to you about the defects. As I was telling you, the defects. What is having 3 point, you understand the definition of 3 sigma, right? I mean 6 sigma, right? 3.4 defects per million opportunity. Okay. So for you to know this, you have to first understand what is DPU. You have to understand what is DPU, and you have to understand what is DPMO. Okay. So let's do this now. First things first, we start our understanding with DPU. So DPU is something which stands for defects per unit. Okay, defects per unit is a number of defects in a sample divided by a number of units sampled. Okay, this might be a little confusing for you if you're just reading this, but now concentrate on the example. And I would request you to pay a lot of attention here, because these are the very basics. All the other things that is going to follow, I mean, after we are done with the basics, is just like adding up to the information. But if the pillars are not strong, the building is not going to be, I mean, the foundation is not going to be strong, right? So let's focus on making our foundations very strong here. So example of calculating a DPU, which stands for defects per unit, guys. So your printing business, I'm just reading this one. I hope you guys are seeing it as well. Your printing business prints custom stationery orders. Each order is considered a unit. 50 orders are randomly selected and inspected, and the following defects are found. Okay, just read this thing again. Just read this, the first 2 lines again. Your printing business prints custom stationery orders. Okay, each order is considered a unit. 50 orders are randomly selected and inspected, and the following defects are found. 2 orders are incomplete. How many orders in total we have? 50 orders. Okay, 1 order is both damaged and incorrect. So how many defects? Like the mobile example that I gave you, it had a problem with the sound, it had a problem with the screen as well. So there were 2 defects. There were 3 orders which were having typo issues. Okay. So in total, how many we have? 2 defects here. Okay. 1 order is both damaged and incorrect. 2 defects here. 3 orders have typo issues. Like while you were typing, you would have given a wrong date, or maybe if it is to do with the invoice or anything, if it is to do with the invoice or the purchasing order, the amount, or the specific materials name, there could be anything to do with the typo error. So something has gone wrong there. All right. And there are 2 orders to be completed. So what is happening here, guys? 6 of the orders have problems, and there are a total of 7 defects out of 50 orders. So we had initially 50 orders, out of which we had 7 defects. Now, if you have to calculate the DPU, guys, very simple. The number of defects that you have divided by the total number of orders that you have. So 7 divided by 50 makes it 0.14. So on average, this is your quality level and each unit of the product on the average contains this number of defects. Okay. I'm not going to read this thing again. I would want you to just spend maybe just a minute more. Okay, just a minute more and make this concept very clear. After this, we are going to DPO. Just read this thing again. The total number of defects that you had comes in the numerator, and the total number of orders that you have comes in the denominator. Once you do the equation, you get the DPU. If anyone comes and asks you tomorrow, like, what is the DPU? This is what you should be talking to them about. Okay, the number of defects divided by the number of orders that you have. All right, thank you. Now let's go to understanding what is DPO. DPO is defects per opportunity. Defects per opportunity is the number of defects in the sample divided by the total number of defect opportunities. Initially, what we did, we just concentrated on the defect. Now, what we are going to do is we are also going to look into the opportunities. Now, each custom stationery order could have 4 defects. Okay. Read it again. Each custom stationery order could have 4 defects. There could be defects in terms of incorrect, and the order itself is incorrect. There could be a problem with a typo. There could be damage issues or incomplete. Therefore, each order has 4 opportunities of defect. Okay. Now, on each order, there are 4 opportunities of defect. Initially, what we did was we were just concentrating on finding out the defects that we have in that order. Here, we are trying to know about the opportunities. Suppose while you are making a coffee, there could be defects with what are the ingredients that goes in there. The ingredients that goes in there is like the milk, the coffee powder, the sugar. Okay, so we are just taking these 3 things for understanding. Okay, so if you consider these things as an opportunity of a problem, that means we have 3 opportunities of a problem in there. The problems could happen because of the coffee powder, which may be of a very substandard. All right, there could be problem with the sugar, which maybe something wrong has happened with the sugar. Okay, or there could be problem with the milk that you're using. So how many opportunities of defect we have in that coffee? 3 defect opportunity we have. And in the same manner, they are trying to talk to us about the opportunities of a problem in order. The problem of, this problems could appear from this having the order incorrect, having a typo on that, having damaged or incomplete. So all in all, we have 4 opportunities. So now again, 50 orders are randomly selected and inspected, and the following defects are found. 2 orders are incomplete. 1 order is both damaged and incorrect. That is 2 defects. 3 orders have typos. It is the same thing that you had here. It is the same thing that you had here. 7 defects. But see how it changes now. Now, initially they were asking you to find about the DPU. The units were considered as the orders. Each order is considered as a unit. Now, the next question is about you finding out the DPO, defects per opportunity. So what do you have to do is, how many orders we had? 50 orders. How many opportunities of a problem were there? Incorrect, typo, damaged, and incomplete. 4. So you have to just multiply 4 and 50, which makes it 200, which comes in the denominator. And in the numerator, you have again the same 7 defects. So 7 divided by 200 makes it 0.035. Okay. In DPU, we were considering one order to be 1 unit, so 50 were there. The question itself was asking about the DPU, defects per unit. In this one, they're asking about defects per opportunity. So in 50 orders, if we have 4 defect opportunity, that means the denominator will become 200. And the number of defects that you have will go to the numerator. So this becomes 7 divided by 200, makes it 0.035. I want you to now take at least 30 seconds to just read this thing again. Not more than that, guys. We do not have much time. There's a lot that we need to understand. But whatever I just told you, please just read this thing again and cement it in your head in such a way that never ever in your life you forget the difference between the DPU and the DPU. These are the very foundations. It depends. It depends, Daniel. It is not fixed for any particular thing. So DPU in terms of services, it depends on the calibration, the one that you would be using. So it depends on the calibration that you would be using for your process. This is to Avash. And for Daniel, what is the acceptable? It also depends on the process that you would be working for. How much is acceptable or not. So guys, all those questions would come, I understand. But now just focus on DPO and DPU. Okay. DPU is done. It is about the unit. The next one is about the DPU, which is talking to you about the number of opportunities into the total number of orders that you have as the denominator. The defect remains the same, which is the 7 divided by 200 makes it 0.035. Perfect. Do not ever forget for the rest of your life. DPU is clear, DPO is clear. Now comes the big fish. This is what the Six Sigma would talk to you about. As I told you, here 3.4 defects per million opportunity, correct? This is what you should be trying to achieve. Which, I mean, see, the thing is, but if I write million, it is just like 1, 2, 3, 4, 5, 6, 7. Just a 7 letter. But I mean, this is something that I do for my tradings, okay? So I'm doing it with you people also. You see the number of zeros we have here. This is a huge figure. And in this figure, if you have to achieve, I mean, this is the target, 0.4 defects, then just imagine how efficient your process needs to be. How efficient it needs to be. Do you see any chance of any scope of making error here? It's going to be a problem, guys. It is going to be a problem. So there's a lot that goes in here. So if I just write million, it might not give you the real sound and effect of what Six Sigma is all about. Okay, since I have written it that way. Again, coming here, now guys, that you have calculated DPO, okay, I'm just going to simplify it out for you. What was the DPO for us? 0.035, correct? Just go now and multiply that with a million. Just go now and multiply the same thing with a million. You are going to get your DPMO. So it will generate 35,000 defects for a million opportunity. Understood? I hope you have.
Yes, sir.
Okay, all right. So we have total 79 people here, all of you. Make this concept very clear. And just for another 30 seconds, I would want you to go through this particular thing again, please. Read it again. Read it again in such a manner that tomorrow the need comes, you can talk to someone about this. What is DPU? What is DPO? What is DPMO? These are the very basics of Lean Six Sigma. Okay, now let me see what I can talk to you guys about next. Okay, just give me a second. Okay, so where were we? Here. So DPU, DPMO, and DPU is done. Now, there are many other things that I have to show you, but I was thinking, let me just talk to you about the DMAIC thing first. So what happens in a real Six Sigma thing? Okay, there are 5 phases that we deal with. Okay, guys, the first 5 phases are define, measure, then you have analyze, then you have improve, and then you have control. Okay, these are the 5 things. And remember one thing, from now onwards, start using acronyms. Okay, we will not be using this define, measure, analyze, improve, and control. What we will be using is DMAIC. This is the acronym that we will be using. Okay, DMAIC. What D stands for is define, what M stands for is measure, and what A stands for is analyze, I for improve, C for control. From today, you are not saying it as define, measure, analyze, improve, control. You start using the acronyms. Like defects per unit, you'd be using DPU. Defects per opportunity, DPO. Defects per million opportunity, DPMO. Okay. Now, DMAIC. I mean, everyone will be talking to you about Six Sigma, this, that, all those things. What is happening in there? It's very, very simple, guys. It is just the logic. Okay. I'm just going to explain it to you from the way I think would make you people understand this concept clearly. The first phase is about define. Okay. This is just talking to you about defining the problem. Defining the problem. Okay. Now there was a question. I mean, it was asked to Einstein, the famous Einstein, guys. It was asked to him as to how important does he feel about having a definition of a problem, defining a problem. What he said, if I was given time, I would invest 99% of my time in defining a problem and 1% of a time in solving it. That is how important defining a problem is. Okay. Until and unless you define your problem well, you will not be able to proceed. And if your definition of the problem itself is wrong, then God saves you. Because maybe once you go to the analyze phase, you would be wondering, where have I come and why I have come here? Defining a problem is very, very important, guys. Make sure to keep this thing very, just understand the fact as to how important this is. I'm just talking about all the other things and for the time being, but understand the importance of define as I told you. Sure. Okay. So measure. What do you do in the measure phase? Measure where the current process is standing. What is the current? I mean, where your process is standing now? If someone has called you, I mean, they've paid you a lot of money. Okay, come and work in my company as a consultant for the next 6 months. Okay, this project is in maybe far east or far west. They have hired you because you know something about Lean Six Sigma. What is this first thing that you're going to do? Okay, of course, defining the problem. Next step is identify where the current process is standing. And for you to do this, there are several metrics that you would be using. Okay, matrices that you'd be using. These are Z-score. These are CP. I'm writing CPK also here. CPK. You'd be using. By the way, CP is process capability. Okay, and PP is process performance. PP, PPK. Now, I'm just writing it here for you so that it becomes easy. Process capability. And there is another thing that I want to let you know now, but it might not make sense. So, but just for you to know that we are using a short-term sigma for this. Okay, we are using a short-term sigma for this, and for the PPK, which is about the process performance, we would be using a long-term sigma. Okay, so that is the basic difference. I'm not getting into this thing for the moment, but yes, let's see if we have time, we'll just get in there as well. So Z-score is about this. It is also known as the sigma level. Now let me just speak to you a little about this sigma level thing. Higher the sigma level, it is good for us. So say suppose you have got a sigma score of 3. It's too hot in the place where I'm explaining it to you from. So, all right. So Z-score, all right. So the Z-score that you need to know is about having a Lean Six Sigma, I mean Z-score of 3, which means, okay, sorry. One thing I told you, the more the Z-score, it is better for you. Okay, the highest that we can achieve is 6. The least that we can achieve is 3. All right. So Z-score of 3 means, guys, having, I'm just writing it out for you. Sorry. Z-score of 3. That means what? You have 1.5 misspelled words on each page. Okay, Z-score of 3. Now, Z-score of 4. All right, what is Z-score of 4? That means one misspelled word per 30 pages in a book. Earlier, it was about the page, 1.5 misspelled words on each page. Now, Z-score of 4 means you have gone to the next level. All right, your process has gone to the next level. One misspelled word per 30 pages in a book. Now, if I have to tell you about the Z-score of maybe Z-score of 5. Now, that would be one misspelled word in a set of encyclopedias. See, why I'm putting in a lot more time in this particular thing is you will start relating. You start relating to it. Maybe from whatever is the time at your place, you'll start relating about Six Sigma from now onwards in a set of encyclopedias. One misspelled word in a set of encyclopedias. Okay, this is when you achieve a z-score of 5. And then comes the one that everyone in this world is looking forward to, which is z-score of 6. That means one misspelled word in all the books contained in the library. Just read this thing, guys, again, and remember, this is important. If you read this, you'll start relating to what sigma level. Okay, if a company says that our sigma level, or we are at 3 sigma level, okay, that means this is what should be there at the back of your mind. Okay, this is good, but not the expected. To be honest with you guys, in a real environment, in a real industrial or official environment, it could be a BPO, it could be a real factory or anywhere, having achieved a z-score of 4 is considered to be kind of good. Is considered to be good. All right. So it is not always possible for you to just go ahead and get a z-score of maybe, you know what, 6. It is very impossible. Okay, it is very tough. So this is what you should remember. And this one, as I told you, is going to be 3.4 defects per million opportunities. Okay, and for the other one, it is going to be 31.96 DPMO. For this one, it is going to be 1350 DPMO. And for the one that you have on top, it says 6210 DPMO. That is that many number of fonts. DPMO. Sorry. That many number of fonts and a million opportunities. So this is what you guys should be aware of. So after talking to you about this particular thing and CPK, which of course, if possible, if the time permits, I'd show you, but there is a lot that has to be covered in here. So this is, again, just understand that these are also different matrix, like the different matrices, just like the way you have z-score. Okay, just like the way you have z-score, the CP, CPK, and PPK also does the same job for you in there. Okay, so now let me okay. So now it would be of a different thing. Okay, so now we'll look into exactly what happens in a real process by taking an analogy of a girl child who is not able to score good marks in an English subject. So the first thing is we are okay. This is for buying so much. Guys, just mute yourself, please, everyone. All right, thank you. So it is about the we are just now we will be now looking into all those 5 phases. Which are those? Okay, these are the things. Okay, because if I just go by this analyze and then improve and then control, it will take maybe a lot. But you need to understand also at the same time what is happening. So analyze phase is where you do the statistical tests. Improve, you understand, like you have the solution, now you are trying to improve it. You would be using, in the higher, normally you'd be using like Pokeyoke. Okay, but while you were doing your black belts, and maybe a little of it would also come in the green belt, where you'd be dealing with design of experiment, which people think is very tough. But But once you start using it, you'll find the essence of it, how exciting this can get. Again, this is about this making of a coffee itself, wherein you'll be using, there are three factors in there. Just take for an example, like sugar, milk, and the coffee powder. What is the quantity that you'd want to have? Okay, what is the quantity of each and everything to make your coffee the best? All right. Also, at the same time, if you'd want to consider the temperature at which you would want your coffee to be served, everything, guys, everything can be done on this DOE, which is design of experiments, which is a great tool, which is with the higher studies, of course. And then finally, control measure is like sustaining the improvement thing that you have done, sustaining the improvement. And for this, you might want to use statistical process control. I'm just writing the short form. Okay, let me write it for you. Statistical process control. Okay, and this will be represented by SPC. So just remember this thing very well. It would be the SPC thing. All right. Now, having said that, now let's look at take an analogy and try to understand as to what actually is happening in any of the process. So say suppose we are taking an example of a girl child who is not good in English subject. Okay, her target is 75% and she's not able to achieve that. So while we are defining a problem, we'll say that her target is 75%. Okay, her target, is to achieve 75% of marks on her final exam. Okay, this is how you'd be defining a problem. This is just an example for you guys to know. Now comes the measure phase. What happens in the measure phase? I mean, in the real life scenario also, wherever you go, this is how you should start relating things. Okay, now in the measure phase, based on the current performance, you would want to evaluate as to how much she is capable of getting with the current skills and knowledge that she has. The problem was she was poor in English subject. Okay, the target is to achieve 75%. This is the problem. So based on the current performance, we would now want to evaluate as to how much he's capable of getting without even practicing anything. This is what even you would do while measuring the current, how a certain process is running. Okay, so based on the current process, based on the current performance, say suppose we got to evaluate that she is able to achieve 55% of the marks. Okay, this is with the current performance, without she doing anything, any extra thing. Now comes the analyze phase. And the analyze phase, what is happening is, now in the analyze phase, we have to determine the gap. Why is the gap? Okay, why is the gap in the performance? Why is it so that she is not able to get the desired score of 75% marks? So I'm just typing it out for you. Why is the gap in the current performance? So where is the gap in the current performance? So this is something that that comes as a question in the analyze phase. Now, once you're doing that, you have to also know for the fact that there's a certain problem that exists, and because of which she's not able to get the desired result. So while you were in the analyze phase, your job would be to determine what is that. Now that you have measured in the analyze phase, you have to determine as to where the problem is coming from. In here, it was realized that the girl child, it could be a boy child also. Okay, no, nothing of that sort. All right. So a girl child, the girl child had a problem with the vocabulary and the grammar. So you see, this girl child had a problem with the vocabulary and the grammar, and this is something which was identified in the analyze phase. And this is what even you guys are going to do. Okay, you have to identify as to where the problem is. So now what is happening is, guys, if I'm just writing it in bracket, you guys must be aware of this formula wherein it says that y is equal to function of x, correct? This is you guys must have read about this a lot, wherein this x becomes the input and y becomes the output. Okay, y becomes the dependent and x becomes the independent. So herein what is happening is we have two problems. Okay, so vocabulary and grammar. So now what is happening here is the problem is coming from x1 and x2. I'm not typing it out anymore. X1 is the vocabulary problem, okay, and X2 is the grammar problem. So this is how you'd want to identify. Why I'm showing you this is just because at the later stage, once you go to the improve phase, there would be equations that you have to deal with, wherein there is a simple linear regression, okay, there are non-linear regression that you have to deal with, and then you have to deal with multilinear regression. So in case if you happen to have more problems, okay, like it is not only about one, there are two. That means you have to deal with a multilinear regression equation. Okay, so just giving you a hint of what would come in the future for you people. So now this is what is happening in the analyze phase. Now you have determined what is the performance problem. Now in the improve phase, sorry about the color. In the improve phase, guys, what would happen is you would recommend the girl to read more storybooks. Okay, this is like when you are trying to improve the situation. So in here you might ask the girl child to read more. Okay, also go for coaching if possible. Okay, and at the same time ask her to do more of a practicing. Okay, these are the things that you would suggest the girl child to go with so that she's able to achieve her results. Now she does whatever you said. Okay, the process does whatever you have recommended. Now she tries. Okay, she tries with the past three papers. I mean the previous question papers. Now whenever they have gone for the whenever she did, after doing all the things, after doing all these things, when she went with the previous question papers, now she is able to get maybe 75% marks now. All right, this is what is happening in the improve phase. So finally comes the control phase. Okay, this is the phase wherein you would want to sustain the improvement that has been done. Sustaining the improvement measures that have been taken. So this is what has to be done in there. Now she should keep reading and practicing for the target score. Okay. From here we started, here we ended. Okay. From define to measure to analyze to improve and then finally to control. Now guys, I give you a situation wherein after doing all these things also, okay, after she doing doing her exercises on the previous question papers, she is able to achieve 75% done. Okay. But again, the exam comes and she's not able to get 75%. She's only getting now 65%. Just giving you an example. Just follow me. Okay. Now she's getting only 65%. This is a cause of worry, correct? Because you would want, after doing everything, so that this girl, this little girl, starts getting whatever you had planned for. But situations would come in your Lean Six Sigma project when it would really not go according to the way you thought of. Be prepared for that. So this is why you need to know the basics very well. Okay. So 65% is something that was actually what do you call that? She's getting now. Now you know when she's getting 65%, you again have to jump to analyze phase because the measure thing is already done. Now 65% is also done. Now where is that 10% coming from? So I'm just writing it here. Okay. Now the rest of the problem that she is having is because of the writing speed that she has. There would be situations wherein the desired result might not come to you very easily. So in those cases, what you have to do is you have to again go and revisit. All right. Try to determine where the problem is. Try to do a root cause analysis, RCA. We'll talk about those things. Okay. So RCA. We'll do RCA, root cause analysis and all, to get down to the basics of it and try to understand as to what would have gone wrong. So these are the things that normally happens in a what do you call it? This one, guys. In the DMAIC process. Okay, just look into this entire thing just maybe for a 30-second from define till here. Okay. Sorry. No, it's fine, I guess. Just feed this thing again. Maybe just another 30 seconds, okay? Okay, guys. So now what is happening is there was a problem in the process, okay? Consider this problem as a problem in the process. There was a problem in the process. You went with the DMAIC approach, okay? You went with the DMAIC approach, which is where I've written it. Okay, this one. You went for the DMAIC approach. Now say suppose, now let me take you to the next thing, which is DFSS, which in essence the formula for, the full form for it would be design for Six Sigma. Okay. In here, the two most common methodologies that you would be using is DMAIC and IDOV. So what is happening in here is, suppose you are trying to completely redesign a new process. All right. So you want to redesign a new process from the very starting, because there are enough. Say suppose you are starting a new company as an entrepreneur. All right. Or there could be a situation wherein the existing process is so bad that you are tired of it, tired of solving it. Okay. You are tired of solving it. You do not want to waste any single minute on the existing process anymore. And you want to go for the new process altogether. All right. So in that situation, what is happening? What is going to happen is you would be going for DFSS. And remember, DMAIC. For DMAIC, we had. Let me take 5 minutes to explain this one, not more than that. But define, measure is the same thing. Okay, define, measure, analyze, improve, and you have control, right? This is the thing that we saw for DMAIC. In DMADV, this is just for you to know, okay? This is just for you to know. We are now talking about design for Six Sigma, DFSS. This is the headline. In DMADV, what happens is the 5 phases are, the initial 3 things are same, which happens to be define, measure, analyze, but the last two things that you see here is design and validate. Okay, design and validate. This is the basic difference what you have in between the DMAIC and DMADV. You are entirely setting it up for a new thing. All right, you are now an entrepreneur or maybe a consultant itself. Okay, but you would want to inform the CEO or anyone who's running the shop, saying that your process is nothing can be done. It's nothing can be done about that process. We need to redo it, and that is when you would take the help of DMADV. These are the two things. There are many. In fact, there are more than 6 to 7, and if I'm not wrong, there are many more than that also. This is designed for Six Sigma, but the basic, the main two things are, main two methodologies are DMADV and IDOV. So DMADV we have seen, we got to understand as to where we need to use DFSS. Now I'll just talk to you about the definition of IDOV, which is the first thing is going to be identify. The next thing is going to be design, optimize, and validate. So, okay, design, measure, analyze, design and validate. Define, measure, analyze, design and validate for DMADV, this one. And the next one is talking to you about the IDOV. These are the DFSS project. This is not DMAIC. DMAIC is for the existing process. So having said that, okay, this thing is done. All right, now I'll quickly, not waste much of your time, but this is something that you should know. So I'll just give you the hierarchy process of how the hierarchy process works in a Lean Six Sigma projects. All right. So sponsor, top executive, and while I'm typing it out for you, let me also let you know that it will change from organization to organization. Okay, it will not be always the same. Some organization will follow this hierarchy, some will follow a different one. So, but whosoever is involved is something that you must be aware of. Then comes champion, then comes process owner. Okay, then comes master black belt. Now this will be a question in your head saying, what is the difference between the master black belt and black belt? Basically, what black belt knows, the master black belt also knows the same thing. Okay, nothing about the knowledge. Maybe he is a bit more tenured. Maybe he has done some more projects than the black belt, and this could be underlying difference between the black belt and the master black belt. Then comes the green belt. Then comes what? Yellow belt. There's a lot in yellow belt, guys. It is, let's see. So this is how the hierarchy works, and especially one segment of it is something that I like to focus on. Champion. Anyone would be called a champion who is like, he's someone who would identify and scope the project. Okay, what is the scope of the project? then he would develop the deployment strategy. See, it is not easy for you to carry on with your Lean Six Sigma projects. Okay, first of all, you are not getting your resources from outside the company. Okay, see, if you happen to be a Lean Six Sigma guy in your own company, then what happens is you would need the help and the commitment of the people who are already working in the process. So when I'm saying that they are already working in the process, you have to understand that they already have their work in their hand. So if they have to come and help you with the project, and if they have to come and help you with the expertise and the knowledge of the process, then they have to leave their current work and come and help you. This becomes a challenge because he also would be reporting. He also would. Please, just mute yourself, guys, please. So he also would be having his own work. Okay, he or she would be having their own work, and they also would be reporting to some managers who actually would be responsible for the work to happen. And in case if they leave their own work and comes and help you and become a part of your Lean Six Sigma project, because you alone will not be able to complete a Lean Six Sigma project. Okay, it's not possible because you need a lot of data, and on those data you have to do your calculations. Of course, there are few projects which you can do alone, like if you know about the Kaizen and all. So Kaizen is again like a change for good and all those things. All right. So if we have time, we'll go to that one as well. So let's understand about the champion things. So champion is someone who is a bridge, who will come and talk to us also, okay, here, and who would be talking with the top executive also, okay, the process owner and the top executive. So he would be having a bird's eye view from a 5,000 feet as well as a 30,000 feet. So you would now start relating as to if you have to know as to who is the one who's very much important for a Lean Six Sigma project. It is a champion. Okay, so you need to know this particular thing in detail. All right. So this is what is happening in the background. So what else do I talk to you about now? Okay. Yes. Do you know about the voice of customer? What is voice of customer? Voice of customer is something which is the opinion that the customer has for the product that you are serving them with. Do they have a good opinion about the services? Do they have a good opinion about the products that you are selling to them? Because you know, customer is the god. If they don't like your product, if they happen to give you a negative review, it is going to be detrimental. Okay, it is going to be like so much. I mean, yes, there is of course a lot of relationship with that also, Elam. I can talk to you about that, but actually we do not have much to go over that. All right. So that is the thing. POC is voice of customer. Yes, Floracle. Yes. So VOC is just about like you having the opinion of the customer. Let me give you an example. Suppose you made an app. All right. You made an app and you launched it in the Play Store or the Apple Store. All right. So why would you launch an app? Because you would want people to come and use your app, right? And tomorrow you might uh, sell it. You might put a price tag for it. But the initial 1,000 customers, you say the initial 1,000 customers, it is free for you. Okay. Then you start selling it. If it is a real good app, imagine how many people would be downloading WhatsApp and Facebook on their mobiles on a daily basis. All right. So maybe you made a game. All right. The video games, like during our days, it was just like those Mario's and all. You remember those big things. Okay. Now you can play all those things in mobiles itself. So this VOC thing is all about the ratings. Like the person downloaded your app, have started using your app, and then out of those 5 rating points, they give you a rating. So those ratings would be, I mean, normally what happens when this Play stores are, you would be, you they, I mean, the Play Store would, or you would be asking your customer to rate it, and from between 1 to 5, okay, 1 to 5. But normally there is a concept that you should be knowing about, which is talking to you about the Likert scale. If you know about the Likert scale, I'm not sure. Likert scale is something which is normally in between 1 to 10. If you're very satisfied with the training, okay, then you'd be going with maybe 9 or 10. If you are really not happy with the training, you would be going with a 1 or 2. This is just an example. So you can go with maybe the product or the service of a company provided to you, maybe the telecom operator, the SIM that you are using. They, after a call, they would be, I mean, if you're talking to the customer service people, they will be talking to you saying that, okay, sir, so this call is getting recorded, okay, for the quality and the monitoring purpose. You now know that, okay, you are not going to, you're going to speak right what it is required for, and it has to be a good one. The conversation has to, I mean, these recorded calls, how do they rate it? Okay, how were they good in solving the customer's query? And after the call, they would be asking you to, sir, this is the thing, you'll be getting a rating and your message, just rate. All those things is just the voice of customer. I mean, what is your opinion about the service that you've just received? Do you understand what I'm trying to say? So this is about the voice of customer thing. There are many things that we should be dealing with, but let me, okay, apart from voice of customers, now that we know voice of customers, there are a few other things, okay? Like voice of business, voice of process, voice of employee. Let me just quickly read a few lines for voice of business. So the voice of business would be something that is related to the return on the investment that you have made, all right? Return on the capital that you have invested, all right? Return on the equity. Like tomorrow, I mean, you as a company, you are selling your shares in the market. So people are coming and buying it, and this is how you are collecting the public fund. Okay. So how much on the return on equity? I mean, this is expected by the customer, right? So how much your company grows, how much, I mean, were you successfully able to allocate the funds where it was supposed to go? So all those things matters a lot, guys. So this is the thing that you need to determine well whenever you are dealing with voice of business. It is just the economic value that has to be added in voice of business. So I've just written the acronym here. I'm not going with the complete thing. So just understand. Okay, maybe I'll just write this final thing. Okay, VO anyway stands for voice of, and then here we have talked about voice of customer. We are now talking about voice of this one, and now let's talk about voice of process. Maybe like next 5 minutes or so, we'll just talk about the voice of this process thing. So what happens in the voice of processes? It is talking to you about the defects, the defect rates, all right, in the process. So how much of a defect is there in the process that you are dealing with? It also talks to you about the cycle time, the throughput. Okay, now I have to show you something. Okay, but right after this, I'm going to show you that. So voice of process would be talking to you about the defect rates in the process, the cycle time. Now, what is cycle time, throughput, and all the other things? I'll show you right after this. Okay, I have some handwritten notes which will help you. So, and whether, I mean, the voice of processes, for that, you might also want to include the on-time delivery rates, whether you are able to deliver the things on time. Okay, so those things would fall under the ambit of voice of process. Now, what comes here is the next one is voice of employee. Now, what is voice of employee? Voice of employee is about the employee satisfaction. You now know that if the employees themselves are dissatisfied, they will not be concentrating on the work, right? So you need to pay a proper focus. You need to pay a proper focus on how to make them happy. All right, how to make your customers happy. So this is one thing that you must be sure of. Just a second, guys. This is one thing that you should be knowing about voice of process and voice of this one, employee. So this is about the voice of employee thing. And what else may I show you now? Okay, before we go to anything else, just look at this. Do you see this cursor here? Okay. Now this is talking to you about the tag time. Guys, normally what happens is, before I show you what is happening in there, you just look at this. This is like for you to understand what is the lead time, what is the throughput time, and what is the cycle time. Okay. So lead time is something which is calculated depending on when the order was received, what time the order was received, and by what time it is going to be delivered to the customer. All right. From the time the order was received till the time it was delivered to the customer would be known as the lead time. All right. Now, what is the throughput time? Throughput time is something which is talking to you about when the raw material was received and what time it was dispatched. Okay. I mean, till the time it was dispatched, that would be calculated as a throughput time for you. So lead time, you have understood. Throughput is from the raw material received till the time it was dispatched to the customer. Now, the third thing is cycle time. Now, this should have been total cycle time. Okay, this one should have been total cycle time. Now, this has 4 processes, as you can see. Okay, 4 processes in here. Now, same thing could be like process A, B, C, D. All right. So what could happen here is, I mean, for your process only, just think as to how many processes are there, small process. So each process would take a certain time to be completed, right? So whatever time it takes to complete a certain process would be the cycle time 1, then cycle time 2, then cycle time 3, and cycle time 4 for you. Cycle time 1, 2, 3, 4. Now what happens here is, if you are adding them up all together, this cycle time 1, 2, 3, and 4, all of it would give you the total cycle time. So this is what you have to know about what is happening for the total cycle time thing. So from the time the first process begins till the time the last process happens, you would want to call it as a this one, the total cycle time. All right. Now, as of now, we have seen 3 things: lead time, throughput time, cycle time. Okay, this is what is happening in the process. But there is another time, one more time, that you need to be very much familiar with, and that is our tag time. Now, before we start with the explanation of the tag time, I would want you to know that tag time is all about customer. Okay, it depends on the demand from the customer. So anything, I mean, if for lead time, you do not need the customer demands to be calculated. Okay, but in the tag time, you need to calculate what is the customer's demand. So tact, this very term is coming from Germany. Okay, this is a German term which came into existence. I mean, people started talking about this tag time after the Second World War. I mean, before the Second World War, when this manufacturing industry was in a boom, like they were doing too good. All right, so this is when they started dealing with this tag time thing. So tag time is this. Okay, now what is the formula for tag time? Available make time per shift divided by customer demand. So imagine, guys, there is 9 hours that you have in your hand. Okay, you have 9 hours of work. So 9 hours have to be now transformed into minutes, which is 540 minutes. All right. So you just have to like multiply. All right. 6 nines are 54. So another 0 for minutes. So 9 hours becomes 5. Pay more attention here. Let it take time. But if this sheet, like the way DPU, DPO, and DPMO is confirmed and sealed in your head, if this sheet is sealed in your head, that means half, I mean, not half, at least the initial battle you have won. Okay, so focus on it. Total time is 9 hours, which is 540 minutes. Now, in there, you have a break of 30 minutes. That is lunch, 30 minutes, and 2 15 minutes tea break or any break. Okay, so 30 minutes and then 2 15 minutes break. So available make time per shift would be 540 minutes, correct? 540 minutes is what we have. I mean, this is not a available make time per shift. We are just calculating it. 540 minutes minus 60 minutes. Where from we got the 60 minutes? 1 30 minute and 2 15 minutes break. So once you do the subtraction, you get 480 minutes. Okay, this happens to be your available make time per shift. Remember, in the tag time, we are excluding the breaks. We are not including the breaks. This is one point that you need to remember well while you are calculating the tag time. Tomorrow, once you go to any of the process as a Lean Six Sigma guy, or else tomorrow maybe you would start questioning in your own process. What is the tag time? You'll just go because you don't have much time as a consultant. Okay, you need to know where it has to be hit. Okay, so while you are working, it will slowly start coming to you. So you'll directly go there and ask for the tag time. I mean, tag time depends on the customer demand, as I told you. So this is one point, first point. Second is we are not including the breaks. So 480 minutes happens to be your numerator. Then customer's demand. What is the customer's demand? 600 products. What do you have to do? Available make time per shift divided by customer demand. So 480 divided by 600. And what is the 60? The 60 is nothing but you have to always calculate your tag time in terms of seconds. Okay. I mean, we are not going for microseconds here, but this is the least thing that is possible for us to go with, right? And in the factory environments, normally it is, I mean, it started from there always, there itself. So you have to calculate with the least possible unit of time, okay, that we are, it's the least possible time that is feasible with our sense of understanding time. So the same thing and multiplied by 60 makes it 48 seconds. So the tag time is 48 seconds here. For making one product, we will need 48 seconds. Perfect. Okay, we are not hurrying on this. Just have a look at it. I'll just grab a glass of water and come back right now. Just be there. Just read this thing again. And remember, there are two things that you need to identify. The tag time depends on the customer demand, and we are not including the breaks. And the third thing is we have to always do it in terms of seconds. The formula is available make time per shift divided by customer demand. Look at it. Okay, guys. I think you have now understood what is the
Hello.
tag time. Hello.
Can I ask something?
Yes, please.
What is the standard talk times so that we have the basis if if this 48 seconds is okay for
No, 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 no. Sorry, I didn't get your name. Your name, please.
this is Remo.
Okay. Hi, Remo. So we do not have any standard tag time. As I told you, tag time is something which depends on the customer's demand. So
Yeah.
now, say suppose the customer is looking for 400 products. So you place 400 here, the entire tag time would be changed. So we do not have
I
any.
get it. Yeah.
Yes, yes, yes. All right.
When it comes to workload distribution, I think it's not possible the 48 seconds per product.
It's
So
say
there should be
suppose
a
they are asking.
standard.
Yeah. So if you are having a good machinery setup, all right, and just take the 600 products as maybe a toothbrush or maybe a toy, a very small toy. Everything is set up. It's actually
Okay.
possible if you think
Okay.
from those terms. All right.
Yeah. Yep.
Okay.
Got
Okay.
it.
Okay. Thanks, Ram.
Thank you. Thank you.
Yeah. Thank you. So this is about the tag time, which depends completely on the customer's demand, and comes now the second one, which is okay. Now we would be talking about the cycle time. How do we apply these processes on the services company? In the service company, see, there would be what do you say? There would be an agreement. Okay, there would be an agreement between you as a company and the people who are giving you the work or the request for the services. So they would be able to help you in that manner. So if you understand what I'm trying to say, so there it depends on what do you call this. There is a term for that that's not coming to my head right now. Like take it as a tad guy, okay? Turn around time kind of. So there you might want to apply this thing as the tag time. Okay, so we'll keep the questions for the last. Okay, I'm sorry to say that, but it's actually there's a lot that we have to cover for the time being. All right. So cycle time. What is cycle time here about? The cycle time is about the total produced parts divided by production run time. Earlier, what we had was available make time per shift divided by customer demand. Now the cycle time is about total produced parts divided by production run time. Here, what is happening is actual time to produce one piece, excluding the breaks. This is about your machinery setup. This is not about the customer's demand anymore. This is about how your machines are functioning, like the equipments that you are using, all right, to manufacture a certain product, how they are functioning. And it is not only about the machines, also the appraisers, also the workers, how well trained they are to perform a certain job. So cycle time is actual time to produce one piece, excluding the breaks. All right. And the formula for it would be total produced parts divided by production runtime. So the total produced parts here is 900 parts. And then you have the production runtime. This time we have taken, just for an easy example, 450 minutes. So total produced parts is 900 and the production runtime here is 450 minutes. So the cycle time is going to be 900. Okay, the same formula, guys. Total produced parts, I mean, not the same formula. This was different. I mean, I'm talking about this cycle time formula. 900 divided by 450 into 60. Okay, you do the maths and you get 1 by 30 seconds. That means one part in 30 seconds. Okay, follow along. It is just talking to you about your machinery setup, the kind of training that the workers working under your company have received. Everything taken into consideration is going to give you the cycle time. So cycle time depends on your setup. It doesn't depend on what the customer is asking for. Then comes the other example for you to understand the cycle time. Here, the total produced part was 1200 and the production runtime was 400 minutes. So depending on this data, if you have to find out what is the cycle time, it is going to be 1200 divided by 400 into 60. All right, that makes it, once you do the thing, it will be 1 by 20 seconds. So in one part, one part will be made in 20 seconds. And the last one, the calculation, I mean, the same thing, the calculation was that one part was made in 30 seconds. In the next one part is made in 20 seconds. Okay, this is the thing that you should be about the cycle time calculation. I request you to just look into it again. Very, very important this is. Just like the way takt time was important, which depended on just when the customer. Now cycle time is about your process, how efficient your process is. Not only the machines, also the people. So just look at this thing again. Okay. Now we see the relationship between the takt time and the cycle time. You now know that takt time is about the customer demand, cycle time is how your process is functioning. If your cycle time is less than takt time, okay, I have written that in this case, we might want to join 2 or 3 processes together. Sorry about the handwriting. It was done in a very, hurry. Okay. So, but not about that. What you have to know is cycle time is less than takt time means your process is good enough to meet the customer's requirement. All right. Your cycle time is now, your cycle time is less than takt time. It means your process is in a good shape. Your process, the one that is there, the existing one, it is enough for you to make the customer happy or make the customer's demand. But in the second scenario, if you see that the cycle time is more than takt time, this is a problem. This is a problem, guys, because you will not be able to finish the order on time. We have to do something to reduce the cycle time. So this is why cycle time and takt times are very important. If the cycle time is more than takt time, it is a cause of worry. Okay, it is a cause of a certain worry. Now, the third thing is if the cycle time is equal to takt time, that means it is kind of good. But who knows? There could be some problems. Okay, it is just equal to takt time. Means anything might go wrong at any moment. So we have to keep working for the continuous improvement. All right. So we have to keep working for the continuous improvement. So this is much required, guys. So remember these 3 points, 1, 2, and 3. So I would want you to see all the things. See, I have not made, I was not the one who actually preached Lean Six Sigma to the world. All these notes are by the scholars around the world. Okay. It is just that I found it somewhere, I liked it, and I have kept it for myself for me to use it. All right. So do not think that I have made it. It is something which has been made by someone, approved by someone, and then used by someone, and globally is the same thing that is being followed. Okay. Now the cycle time is less than takt time. That means the process is good. If the cycle time is more than takt time, that means the process is not in a good shape. Cycle time is equal to takt time, good, but we have to keep working for the continuous improvement. These are the 3 things that we should be focusing on. All right. Comes the next thing. What is the throughput time? Remember, in throughput time, the formula will, it is raw material to dispatch. Where is that? Raw material to dispatch, right? So what is happening here is the formula for the throughput time would be 1 by cycle time. Now you know what the cycle time is. You have to just do 1 by cycle time. So if the cycle time, say suppose for any of the processes 20 minutes, then the throughput time will be 1 by 20 minutes. Okay. Throughput time is going to be 1 by cycle time. So the cycle time, if it is 20 minutes, the throughput time is going to be 1 by 20 minutes. Now, the units should be made same. So if it is 1 by 20, that means we have to put 60 on top, and you have to, as it is, like the 20 is in the denominator. So this becomes 60 by 20. All right. So throughput is 1 by 20, and this becomes 60 by 20. That makes it, once you divide it, it becomes 3. That means you have 3 units per hour. Okay. So the throughput is 3 units per hour. So if you have 8 hours in your hand, that makes it 3 into 8 hours. 3 into 8 hours, which is 24 units per day. Okay, the unit have to be made same. So if it is 1 by 20, this will be 60 and 20. This is the only thing. Like in 1 hour, you are making, it takes 20 minutes as a cycle time. So in 1 hour, you're making 3 units. So for 8 hours, you'll be making 24 units. That is it. Okay, so this is something that you must remember as to what the throughput time is. Now guys, you know the takt time, the relationship between the cycle time and the takt time. You now know the throughput time as well. Let's look at the final thing, which is the lead time, but I don't think so there is much to be discussed in here. It is just that the work in progress divided by the throughput. This is also taken from a note itself. So total time is the total time a unit takes from the time the work is requested to the time it is delivered. So work in progress divided by the throughput. Suppose the work in progress is like 50 units. This is the one that has been asked by the customer, and your throughput is 10 units per day. That means the lead time is going to be 5 days. That is it. Just easy as the calculation goes. So the work in progress is 50 units. The throughput is 10. So the lead time happens to be 50 by 10. So it will tell you about what the work in progress is going to be like. What the lead time is going to be like. So this is about the lead time thing. Work in progress is 50 units. Throughput is 10 units per day. So the lead time happens to be 50 divided by 10, which makes it 5 days. So it will take 5 days for you as a company to make the product delivered to the customer. So this is about the lead time thing. And we have we have talked about this lead time, throughput time, and cycle time. So lead time, throughput time, and cycle time is depending on your process, and takt time is something which is depending on the, what do you call this? It depends on the customer. Okay, so this is something I really wanted to discuss with you people. Now just give me a second. But you have understood, I guess you guys have understood and have now also started relating to what it is all about, correct? Now it's the right time that I take you to, one second. Yes, there are a few things that we need to clear our concept on. I know it is very easy for some of you, but if not, please just be there with me. Guys, what is mean? Gosh, just a second. Just now it was. Just a second, guys. It was working fine on this mic. And this is also not working good. Anyways, guys, I'll just try to use my hand itself. Guys, we have 10 numbers, okay, like 10, 11, 14, 9, and 6. If someone comes and asks us about what is the mean, I know most of you would be knowing what it is, but let's just understand it again, just maybe 30 seconds. So mean is nothing but you having all the numbers added up and then divided by the total count of it. So for this, the total count is going to be 10 plus 11, which is 21, plus 14 makes it 25. Average, yes, of course, the average of it. All right. So 25, then again 11, 35 plus 15, then makes it 50. So 50 by the total count of it, how many are there? 5. That makes it 10. Correct. So this 10 happens to be the mean. This 10 happens to be the mean for it. All right. So this is what is happening in here. Now for median, I'll just have to shift to the next one. Okay, before that, I'd like to let you know about the mode. Now we have these numbers that we have. Okay, so mean is clear because you will only deal with all these things, that stuff. So if the basics are clear, the rest of the things is also going to fall in place. So this is the mode. I mean, this set of data has been given to you, and you were asked to find the mode. So what is the mode? Mode is the most occurring item. So how would you remember it? Most occurring item. Okay. So in this case, sorry, I'm not able to see the chart's case now. You're able to see my screen, right, everyone?
No, sir, you stop your screen share.
Okay, sorry. Now is it fine? Yeah, anyone? Can anyone
Yes, sir.
confirm?
Yes.
Okay.
Yes, sir.
Okay, thank you. So now we will be talking about the mode thing. Okay, so what is the mode thing here? It is just about the most occurring item. So in this case, the mode is going to be 10. So we have 10, 11, 14, 9, 6, and 10. So the most occurring item here is 10, and that happens to be our mode. All right. Similarly, now that we have learned about the mean and the mode, now we'd like to know a little more about what is median. So mean and mode is very easy. Even median is easy. So let's look into what the median is about. Median is nothing but you have to first take the data, arrange it in the ascending or the descending order. For example, we have 10, 11, 14, 9, and 6. Okay, the first thing that you need to do with this data is you have to arrange it in ascending or descending order. So we'll be arranging it in ascending order. So let's do it. 6, 9, 10, 11, and 14. All right. So we have done whatever was required to be done. Now median is nothing but the middle value when we arrange any set of numbers in ascending or descending order. So we have already arranged it. We have already arranged it. Now the median is going to be the center value, the middle value. So in this case, the middle value happens to be this one. Okay. So the median for us here is going to be median is going to be, these are very basics, but still I'm taking a little more time to make you people understand. So we'll quickly finish in next 5 minutes maybe. So this one, imagine this is an even data set. I mean, this is an odd data set. If you have an even data set, what happens? So suppose you have 10, 11, 14, 9, 6, 11. So this is an even data set. So for this one, again, you have to first arrange it in ascending or a descending order. So what you have to do is 6, 9, 10, 11, 11, and 14. All right. So you have arranged it well now. Now, how are you going to select? Because you do not have any middle value here. How are you going to select that? What you have to do is you have to take an average of the middle two. This is how you're going to do it. So if you take the average, it is 21 divided by 2, which happens to be 10.5. And this becomes the median for you. This becomes the median for you. This is something that you need to know very well. Mean is something which is a geometric mean. Okay. This mean is also known as geometric mean. Okay. Then comes the mode. Okay. Mode is known as frequency mean. Just a good to know information. Okay. You'll start relating to it maybe when you start working. Frequency mean. And then comes the median, which is known as positional mean. Again, it stopped working. So sorry for that, guys. Just a moment. So now, this was 40 and 40 and 9 and 6. This is known as median is known as positional mean. So mean is the normal mean is known as geometric mean. The median is known as positional mean, and the mode is known as the frequency mean. So if this is your bell curve, okay, say suppose it is perfectly symmetric. The top portion that you see here, this is the most frequently occurring thing, right? So this happens to be your mode, okay? And since it is the most occurring thing in here, and hence it would be called as frequency mean. That is the only reason it is called as frequency mean. Okay. Now we would quickly, we have to understand this one first. Okay, just a second. Now that we have understood mode, mean, mode, and median, The next job for us is to understand what is range. What is range? Guys, the range is something which is the difference between the lowest and the highest value. So if I have to write about the range thing, say suppose this is the set of number that we have here: 6, 9, 10, 11, 11, and 14. Okay. What is going to be the range for us? It is just going to be the highest number minus the lowest number in here. So 14 is the highest number, this one, and 6 is the lowest number, right? So what you do is 14 minus 6, it makes it 8. So 8 happens to be your range. Remember, very important. Now the father of everything, okay? Now the main thing, which is standard deviation. Now, what is standard deviation? Standard deviation is it is just, if I'm drawing here, like normally how your graph is going to look like in the environment, okay? This will be your mean. Suppose this is a straight line, sorry for the thing. This is your mean. And normally what is happening, for the 6 sigma, 1 standard deviation, 2 standard deviation, 3 standard deviation. Here also you'll have 1 standard, 2 standard, 3 standard deviation. So this is minus 3, minus 2, minus 1. You have plus 1, plus 2, plus 3. So together it will be 6 standard deviation, which is represented by a sigma. This is in essence is your 6 sigma thing, guys. This in essence here is your 6 sigma. So hence I told you it is the father of all, because now we would want to calculate what is this. This is the sigma thing. But again, when we are calculating standard deviation, we must know that the standard deviation could be for the sample or the population. Now I have to show you a different thing. Now this, say suppose, is a population. Okay. Okay. Just take it as a population. So this is the population. Okay. Now imagine, so the elections are happening in US right now, right? So yesterday I was talking to my students about, I gave this example, and I just explained the thing for this one. What is happening in there is now the 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 news channels will start showing up the exit polls. You know what the exit polls are, right? So they would be now starting to show the exit polls as to who is achieving. Who is getting what. How much of a vote they are getting. Okay, so they would start talking about all those things now. So how do you do it? Do you think it is going to be easy if you just go and ask each and everyone in that country to whom they are voting for? It is going to take a lot of time, right? It is going to take a lot of, maybe I'll just write here for you: time, effort, money, okay, other resources. So it is going to take a lot of time for, time, effort, and money and other resources for them to go and ask for the opinion for each and every guys out there. Every person out there who is eligible to give vote. Okay. So what is happening here is they will go, for the exit poll results and all, they will go to us. Out of those 50 or 51 states that they have, they will go to certain states. Like, if this is, take it as one state, take it as another state. Okay. They will go to these states and take their opinion, as to what they are feeling about. They will go to prominent states itself, like New York, Washington, or maybe like far off, like Virginia and all. So they'll go and take their opinion. So this all happens to be, this becomes your sample. This becomes your sample. Okay. Guys, just turn off your mic, please. This happens to be your sample. And why I'm talking to you about all these things is just because the standard deviation. Hello? I'm not able to hear you clearly. Hello? Guys, please turn off your mic. So it is about the population. Okay, this is the entire set of population. Then you have sample here. You must be wondering as to why I'm saying this thing now, right? As to what is the reason? Because the standard deviation thing that you see, guys, here. Okay. Okay, no more. We don't want that in the training, guys. Please mute yourself. Erwin, is it you? If you could turn off your mic, please.
It's not possible to turn off from your side.
Okay, can one of you see that if my voice is audible, right? Everyone?
Yes, sir.
Okay. So the thing is, but why I actually showed you about the population and sample, because the standard deviation has a formula which is different for population and sample. So first of all, let's look into the formula for the sample. All right. And before doing that, just wanted to let you know. I mean, you might want to know as to what standard deviation, and then you have variance. So what is variance and what is standard deviation? Okay, variance is nothing but just the square of standard deviation. Say suppose variance is just equal to, I'm just writing standard deviation here, standard deviation square. The square of standard deviation makes this one. Just a moment. Do not get into this thing. This will be. I'll let you know in some time to come. This will be a problem. Just understand the formula first, okay? The formula is going to be for the sample. It is going to be. It is represented by small s in terms of sample when it comes to sample. So there's going to be the square root of sigma, and then you have x minus x bar whole square, and then you have n minus 1. Okay, this is the thing. This is the standard deviation formula for the samples. For the samples, these are the samples, right? So this is how you're going to calculate the standard deviation for these samples. Now, how do we calculate standard deviation for the what do you call this? The population. For that, what you have to do is, this is the symbol for the population. I'm just writing it here. So for the standard deviation for the population, it is going to be sigma x minus mu whole square. This is mu, okay? Mu whole square divided by n. Now you must be noticing that both the formulas. Before I proceed to the other things, this s is just the way the standard deviation is represented when it comes to sample. This is the same sigma, okay, which is talking about the standard deviation itself, but now it is talking about the population standard deviation. This is sample standard deviation. X bar is nothing but the mean. X bar is the mean. And this mu thing that you see here, this mu is also the mean, but just this mu is for the population, this x bar is for the sample. So mu is also the mean thing. N, which is represented by small n, is the total number of observations. Total number of observations. And the same thing goes out to the capital N as well. I mean, this is for the population and this small n is for the sample. It is the same thing. The only thing that would come to your mind is about this n minus 1. Okay, this n minus 1. Now you would be asking why this n minus 1. This n minus 1 is just there in the formula. Just take it as it is. But if I have to explain you why we don't have the complete n and n minus 1, it's just because we are not measuring the complete population out here. We're just talking about the sample. So this is about the sample thing only, correct? Okay, and this is the reason we are just doing this n minus 1 thing. But remember, this n minus 1 thing will be there always. Okay, and what happens if this bracket comes on the left hand side? It will be s square sigma x minus x bar whole square divided by n minus 1. And if the square root comes on the left hand side, it would be sigma x minus mu whole square divided by capital N. So whenever the square is on the left hand side, this becomes the variance for you. This becomes the variance for you. This is called as the variance. Variance is just the square of the standard deviation. Variance is just the square of the standard deviation. Why we are taking so much effort in understanding mean, mode, median, range, standard deviation? It's just because if we have no idea about these basic things, then I mean the software, the statistical software is going to do all the dirty jobs for you guys. You do not need to do all these things by hand. But at the same time, remember, you need to know this. If you don't know this, then the entire calculations or whatever is happening in the background, you'll miss out on all those things. So having said that, now that we know as to what the formula is, we will try to plot one example and we'll show you as to what is happening in the real environment. Okay. Now, say suppose what was the formula for us? I'm just writing it here maybe. Okay, I'm just writing the formula here for the sample thing. Okay, S, it was equal to square root of sigma x minus x bar whole square divided by n minus 1. This is the formula that we'll look at. We'll take an example and try to understand. We have 6 observations like 100, 101, 99, 102, 98, and we have 100. Okay. The first thing, consider this to be x. Okay. Consider these things to be x. Now, the second step that we need to do is x minus x bar. Now, what is x bar? X bar is the average of this 6 data points that we have. And what is the average of it? 100 plus 101 plus 99 makes it 300. And then 102 plus 98, 200 plus 100. That means it is 600. So 600 divided by 6, because we have 6 data points here, 1, 2, 3, 4, 5, 6. That means the average becomes 100. All right. So now what is happening is for x minus x bar here will be 100 minus 100 for this. Sorry, I'll just change the color maybe for you to understand. So 100 minus 100 minus, I'm just putting the averages here, okay? 100, then 100, then 100, then 100 again, then 100 again, okay? What is happening here is 100 minus 100 becomes 0. This is just the average, guys. This one that you see is just this part, the average of all these numbers. So 0. X minus X bar will be 0 here. Then it will be 1. Then it will be minus 1. 99 minus 100 will be minus 1. 102 minus 100 will be 2. 98 minus 100 will be minus 2. And 100 minus 100 will be 0. Now what will happen is, now you have to go for X minus X bar whole square, the main thing. So we'll go for that. X minus X bar whole square. Now 0 square will be 0. 1 whole square will be 1. Minus 1 whole square will be 1. 2 whole square will be 4. Minus 2 whole square will be again 4. And 0 whole square will be again 0. So the total of it would be, when you say sigma, so sigma X minus X bar whole square is going to be 10. Correct? As of now, you guys are with me, right? So this is how we have calculated X minus X bar whole square. So in our formula, it says that, okay, let's bring the square this side. Okay, let's make it a variance. As I told you, the square of the standard deviation is the variance. So, oh, sorry. So now what we are doing is, we are plotting just this. X minus X bar whole square divided by n minus 1. So this is our numerator. So s squared becomes 10. This becomes a numerator. And what is n minus 1? How many observations we have here? 1, 2, 3, 4, 5, 6. So since it is for the sample, see, if it was for the population, then it would have been only n. Since we are doing it for the sample, so it is n minus 1. So since it is for the sample, so it is going to be 6 minus 1, right? 6 minus 1 becomes how much? 6 minus 1, that is s square is equal to 10 divided by 5. We do the thing, we get 2. So if someone comes and asks us, okay, what is the variance? What is the variance of this calculation? The variance is going to be this one. And if someone comes and asks us as to what is the standard deviation of this, you have to simply do s is equal to square root of 2, which is nothing but 1.414. That is it. And this is nothing but this standard deviation. The standard deviation 1, standard deviation 2, standard deviation 3. Then again here also this side. So this is how the standard deviation is being worked upon. This is what is happening in the background. This is what the statistical software is going to do for you. So since we have spoken about all these things, I think, just give me a second. It's not coming down anymore. Okay, there is another thing that I really wanted to show you. Maybe just give me a second, guys. Okay, I'll just use this space itself, okay? Guys, if the total thing is 100, okay? You have total 100 data points. Just imagine you have total like this 100 data points. 100 and this is 1. Now, this can be divided into 4 quartiles. Like I'm talking to now, I'm talking to you about the percentile. So for the percentile, what is happening is this total entire area would be 100. So if I'm talking about the 4 quartiles, like this becomes the first quartile. Then till here becomes the second quartile. Then here becomes the third quartile. And the final one is the fourth quartile. Okay. So remember, just like the way you have percentiles which divides any set of numbers into 99 parts excluding the 100, I mean, excluding the one first thing. I mean, you can take it as, of course, 100 parts itself. And then the quartile happens to be when you are dividing it into 4 parts. Okay, quartile 1, 2, 3, and 4. Now, the next thing that you need to know about this particular thing is, interquartile range. Interquartile range. Interquartile range is nothing but Q3. I mean, sorry, this is Q1, this is Q2, this is Q3, this is Q4. Interquartile range, whenever they ask you about interquartile range, just remember you have to subtract Q1 from Q3. Sorry, you have to subtract Q1 from Q3. That is going to give you the interquartile range. So this is all that I wanted to discuss. Percentile is 100 parts, quartile is 25% of it each. So interquartile range is going to be Q3 minus Q1. So this is about the interquartile range. So we have discussed the mean, mode, median, range, standard deviation, and the percentiles. The most important of it all. Okay. All right. So having said that, just looking to just give me a second more. What else we can. What else can we look into now?
Can you tell us something about percentile?
Yes, yes, tell me.
Can you tell us something about the percentile?
Percentile is something. Percentile is the median that divides the data into 99 parts. All right. It divides a certain data into 99 parts, and that is how you would want to take it. Just like the way I told you about this line, if you are just dividing it into, I mean, this one thing will not be considered, right? So for that matter, all the thing that you have here, if it is 100, that is how you need to calculate the percentile. For the calculation of the percentiles, there are some calculations. Sorry, the calculations are there definitely, but it is going to be a little time consuming if we just go in there. But it is just like, again, getting into the main things. All right. So for this, just remember one formula that I can give you for percentile. If you really want to know much about it, you can calculate the percentile, calculate the the location of the percentile as Pn divided by 100, wherein this n becomes the number in the data set. Numbers in the P becomes the percentile, E becomes the percentile, excuse me, percentile, and n becomes the number in the data set. Okay. Sorry, I didn't get your name, please.
Debashish.
Okay, Debashish. So number in the data set. So P is the percentile and n is the number in the data set. IQR, as I told you, is Q3 minus Q1. What else, guys? Just a moment. VOC we have done. Measuring of the thing also we done. Y is equal to Fx. Now we'll take a break in maybe 10 minutes or so, okay? But before we take a break, there are a few, I mean, after we are done with the break, we'll straight away jump into the lean tools. And after we are done with the lean tools, then a little of what the CPK or CP or CPK is all about that I'll talk to you about. But before that, there are a few jargons that I would want you guys to use in case I mean, in your office and all. Okay, so let's look at those. Mimosa. Does anyone know about it? Let me just ask you. You can turn on your mic and let me know. Does anyone know about it? Okay, not a problem. It is just V would stand for the vision. Okay, M for the mission. Then you have O for the objectives. S for the strategies. And A for the action plan. Okay, so you must, if you can use it, start using it in your office itself from now on. So Vimosa is just like if you tomorrow become an entrepreneur, and this is how you'd want to plan your organization. Vision is here talking about the dream that you have. Okay. Mission, what and why. Objectives, how much of that. Strategies is like how are you going to achieve it? And then the action plans, who will do, by when. Who will, you might be thinking as to what track we are following now, but this is just before the break. So I thought, let me just talk to you about this thing so that you remember this particular thing and start using it as well. So Vimosa is all about you having a vision for the company, or maybe the project also that you are a part of. The mission, the objectives, the strategies that you'll be using, that is how, and the action plan. So tomorrow you become a Lean Six Sigma consultant, you would want to remember this thing. In case if you find yourself in a place of nowhere, come to the basics, see what has to be done, and in case if you're lost, you'll just get back to the track. Now another thing that I would want to let you know about is SMART. Okay, this SMART is talking to you about this 6 things, which is like specific.
Password.
Yeah. Measurable.
Accountable.
Achievable. Yes. Relevant. And time bound.
Time bound.
Yep.
Baka mag-block yan. Hindi mag-block yun. Wala namang...
So you guys might want to start using
controller.
it. Maybe in your office thing and see as to how beneficial it gets from there on. So in this first session of last 3 hours, we have dealt with the very basics. We now know what the cycle time is. We now know what the stack time is, the lead time. Lead time we know, the throughput time we know. Now we also got to know about what else?
Yung iba kasi di ba kaya may butas dito? Yan yan eh.
Hello. The DPUs, the DPMOs, and the DPUs. And also we talked about the calculation of the mean, the median, the mode. We understood what is standard deviation, how it is taking shape, and we talked about the lean thing, the Muda, Mura, and Muri, and what, and pretty much that. And we understood about the common cause variation and the special cause variation, wherein we need to apply what. And we talked about voice of customer, the voice of business, the voice of employees, and the voice of process. What else we have? Okay, I think we'll go for a break now. The break is going to be for 20 to 25 minutes. And I'll just put a timer in here for you people. And once you come, we'll start with the rest of the things. All right.
Can you scroll up a little, please?
Yes. Is this fine?
Yes, yes. Thank you.
Okay, welcome. So we'll just take a break of 25 minutes, okay? So I'm going to move from this one. I don't know if it was remote. I'm just going to move from here and I'm going to place a different tab in here. I'll just place a timer for you people.
Sir, please provide our copy of your recordings so we can review.
I think IMC will provide you that, but I'm really not sure. You must write them a message, and I think they would be dealing with that. Hello guys, welcome back. And the things that we have done as of now was just about understanding the very basics of it. Now we'll try to understand the lean thing, okay? How and where we can make use of it and all those things, we'll just try to understand. Now, just give me a second. Okay, so lean, by now you know that lean is something that we would be using in mainly where for the waste, for the removal of the waste, for the simplification of the process, and all those things. Correct. So first of all, we should know as to how it is going to help us. So let's look into that now. So lean. The things that it will be helping us or helping out us would be, it would help us in the reduction of the, first of all, let's look into the reduction, okay? It would help us by reduction in terms of, guys, just mute yourself now, please. Everyone out there. Reduction of the cost. This is the first thing, reduction of the cost. The second thing that would come into picture is the defects. We need to reduce the defects. The third thing would be to reduce the lead time, because we would now want our products to reach the customer at the earliest, right? This is how they are going to stick with us for the long term. Otherwise, you know how the competition is there in the market. If not us, someone else is going to deliver the same product to them at, earlier than us. So these are a few things that we should be knowing about. Also, lean will help us in reduction of the inventory. So we know that inventory becomes a challenge for us, because if we have a big inventory, then we have to be the raw material or the finished products. But inventory is something that we would be focusing on, reduction of the inventory. Okay. Then of course comes the waste. So waste is something we, as I told you, you have to revisit this Tim Woods thing again. TIMOODS, to understand. And the first project that you might want to do would be, say suppose, for anything, for any project that you would want to start with Lean Six Sigma, first of all, I've seen most of the time it is about the lean thing, and most of it would be in reduction of the waste. So learn this Tim Woods thing, the one which we discussed at the very starting of our class today, very well. This is going to help you in each and every step of your life. So this was about talking about the reduction. There is something which we have to increase with the help of lean, right? So what are those things? Let's look into those things now. So it is about increase, okay? Increase in terms of productivity. We need to formulate the process in such a way by removal of the waste, by simplification of the process, so that our productivity increases. Okay. The second thing that we should be wary about is the customer satisfaction. Very much important. We want our customers to be satisfied. So if they are not happy with whatever we are delivering out to them, then they are not going to come back to us, right? So it is going to be a problem for the business. And this is not a business that we are running for maybe a year or two. This is something that we are thinking to run for the rest of our lives. So we should be very serious about the things that we are doing inside the process. All right. So this is about the customer satisfaction. Third thing, the main thing, we need to focus on increasing the profit. Right? We all need to start thinking in that way. The customer responsiveness is something that if you can relate to, customers responsiveness, because we would want them to be very active. Okay, I mean, in terms of, see, if they're happy, they will try, I mean, they'll write a note for you. So when, if just take an example of an app that you have made and you have launched it in one of the play stores. So what happens is after we asking them about their opinion about the ratings that they're going to give, the next thing that we ask them is, okay, if you like our product, then would you just spend a couple of minutes and write a note about it? That, I mean, what is that best thing that you liked about our product? So this is going to, I mean, the whole lean thing is going to increase the customer responsiveness. The fifth thing that I want to write here is about increasing the capacity. Because if your process is filled with junk, then you might really not know as to what the real capacity of your process is all okay. So it really depends on that. So you need to, increase the capacity. I mean, the capacity is also increased with the help of the lean. Sixth, quality. Yes, of course. If we are not focusing on the quality, see, when I'm talking about the quality, then I should talk to you about this other thing also, which is cost of good quality and cost of poor quality. COPQ, COGQ. Normally, people will not talk much about COGQ, it is understood, but COPQ is something which is cost of poor quality. So cost of poor quality is what, you know, guys. So if you are not, see, cost of good quality would be to focus and put your time, effort, and money on the trainings. All right. You give your employees the right training. Okay. So that tomorrow there is no problem in the process and they also are like charged up and you have to keep them motivated somehow. Another thing that you have to be very much wary of is the auditing. Whatever product you make, okay, it has to have a sharp quality, I mean, audit check before it goes to the customer. Because otherwise, I mean, these are extra costs, okay? So you make a product and you give it to the customer. But just imagine now you're putting one extra department for the auditing. Okay, this is one extra thing that you are putting in there. But what it essentially does is it helps us in making your customers satisfied. They now would be dealing with such products which has passed the quality check. So this is very much important. All right. And now what is cost of poor quality? This is cost of poor quality. Okay, COPQ. What is cost of poor quality? Like if you're not focusing on the trainings, the audits, and all those things, what happens is tomorrow the product that you're selling out to your customer, the customer might find it to be not doing the purpose for what he has purchased it from you. So he might come and return it back to you. He might not stop there. He might give a bad review. He might write publicly. Okay, this brings in bad reputation for your company. All right, and at the same time, whenever he's doing it, I mean, it is just about returning the product, right? So that becomes a rework for you. Okay, so anything to avoid the rework, the scraps, the returns, all those things, if you have to avoid, then you have to focus particularly on the trainings and the audits and all those essential things which is going to make your product look good and also behave good. I mean, it should serve the purpose for what it was made. I mean, when you launch a product, it is all about the warranty thing, 2 years warranty, 3 years warranty. What for? This is just for the customers to be satisfied with the notion that yes, it has been quality checked, and the company itself are saying that they are going to provide us a warranty. All those things, all right. So yes, so that you do not have to spend more money later, you have to put in your efforts for the right trainings and audits. So this is about the quality thing. So the next thing that I would want to write here is timely delivery, on-time delivery. On-time delivery. See, what is happening in the Amazons and the Flipkarts and all. So these people are saying, I mean, just take an example of this Amazon. So if there is a way that you can become a Prime member in the Amazon, it's just paying some extra yearly fees or something, you can become a Prime member. So what is the facility that you get in there? So it is the earliest time that you'll be receiving your product, the one that you have ordered for. Okay, so this helps. Mr. Hamid, can you just mute your mic, please?
Can you please mute?
Okay, so it was about this thing as of now. Okay, so what lean helps us in reduction and what lean helps us by increasing in. So the cost, defects, the lead time, the inventory, the waste, it'll go down. So if I have to just draw it for you, it will be coming down, guys. And this is what you should know. Okay, it should be coming down. And the ones on the right, they should go high. Okay, they should go high. And this is how you should identify the things. All right, the one which is coming down and the one which is going high. Now, this is about the lean thing, what it does. Now, let's see a few of the lean tools that we would be using. So the first thing, and which I feel that should be used a lot, especially in the offices. All right, especially in the offices, because it's a very common practice, but at the same time, it's very beneficial because it saves in a lot of time, and you have a different way of looking at it also. So without speaking much, let me just write it for you. It is 5S. So normally 5S is also coming from Japan. So you have those 5 words, which is Siri, Siton, Siso, Siketsu, and Shitsuke. Okay. But for that, if you have to have an English word, it is going to be sort, set in order, shine, standardize, and the final thing would be to sustain the thing that you have done in there. And this 5S, I mean, now people have started adding one more S to it. And that final S, I'm just remember it as 5S itself. Do not go for the sixth one unless you find it somewhere, in Google itself, and be sure of what it is. Okay.
Safety.
Hello.
It's safety.
Yes, it is safety. Yes, correct. Who are you? What's your name?
Suyog.
Hi, Shivam. Thank you. Okay, so the first thing is sort. So it is about all the unneeded tools.
All the recording of the session, please.
I did not get you.
I'll need to have all the recording of this session.
Okay, Hanan, for that, I think you should be speaking with the IMC. All right, just speak with them after the training session, maybe.
Okay.
Perfect. Yes, yes. So kindly mute everyone for the time being. It is just maybe 1 hour and 20 minutes that we are left with. So yeah, so sort is about, guys, all the unneeded tools, parts, and supplies are removed from the area. All the unneeded tools have to be removed. I don't know where this black line came from. Okay, all the unneeded tools that we have to be has to be removed from the work area. Normally, sort is something that you'd be using in your work desk. Okay, now comes the set in order, which is talking to us about a place for everything, and everything is in its place. Okay, I'm just a place for, sorry, this is E. Okay, everything and everything is in its place, right? So these are the two things. First of all, sort, set in order. Then comes shine, the place where you sit, the workstation. You should clean it. This is all that I want to write. This is that single word that I want to write here. Standardization is the cleaning and identification methods are consistently applied. So once you have cleaned it, you have to maintain the standardization. Okay, how do you do it? Cleaning and identification methods are consistently applied. So this is all that I can read about this particular standardization. Now that you have done all the first 4 steps, the next one is about the sustain thing, which is about sustaining and making this 5S as a habit. Okay, so the 5S, making it a habit. That is all I can say. Okay, making it a habit. So this is about it. And then comes the safety. Work areas are safe. You have to consider this to understand that the work area should be safe and free of hazardous or dangerous condition. Hazardous conditions. Okay. So this is all that I want to let you know about the 5S. So in your office environment, I'm not sure if you guys are working from home or if the office has started, but this is something which has to be maintained well. If you see, I'll tell you, you are only going to start with the lean thing. First of all, understand these things. Okay, these are the things that you'll be starting with. What lean helps in this reduction and this increase. Okay, once you're done with that, this is the first tool that we saw in what do you call this, and the lean thing. Now let me just talk to you about this thing, which is Kanban. What is Kanban? It's a visual sign. Okay, it has, this is also coming from Japan. So just imagine how many things we have. So Kan means visual sign, visual or visual sign. Okay, and ban means card. So a visual card to trigger required actions, essentially a visual signal. So visual control for signaling for a scheduling system to achieve just in time meet customer requirement, not to use if any. Okay, where will you use Kanban? Where it is, where the process is, very active. Okay, you're not going to use Kanban for like the process which is generally not that active. Not much is happening in there. So suppose there is a low customer demand. In those areas, those places you might not want to use the Kanban. But where it is high, suppose, how do I tell you? say suppose a security check, the one where, I mean, if you go to the mall, when you go to park your car, the vehicle, so wherever you go, I mean, there would be a green light and a red light, right? So if only when they verify your vehicle, they check that, I mean, they place those mirrors and everything below your cars, they check, and then only the green light thing happens. So this is just an example of a Kanban. All right. So this is how you would want to know about the Kanban thing, and official thing also I'm just going to talk about. But before that, in your car, you have a fuel gauge, right? I mean, the one which is showing you as to how much of a fuel is there in your car. Okay, that particular reading, the meter. That is also a kind of example of a Kanban thing, which is visually representing you as to whether how much of a fuel you have in your vehicle. So this is one thing. Now, normally in the office environment, what happens is you would be having a board. You would be having a board like this, in where, like with different colors, okay? You would be having like this color, which would be talking about a particular process or something. Then you'd be having this. Then you might be having this one, which is just telling you as to where the process is. Okay, I mean, what is in queue, what is in progress. Suppose that it, I mean, especially in the big production areas, they will be always in need of raw materials, right? In case of a shortfall, the entire production will stop. So in case if they happen to see that it is going to be the last lot, I mean, it is the second last lot, and after this, it is going to be the last lot. Maybe the last lot is only going to stay for maybe 2 days or something. So then the card, I mean, in this board itself, it would be shown to replenish the replenishment for the this one. What do you call this? Raw material is required. So by looking here, by looking at this board, the person who is in charge of what do you say? For getting the raw materials, he will start acting on it, and he will make sure that we are not in short of the raw materials. So this is something which would be used in boards itself. I mean, in offices itself. Another way of representing it would be, say, suppose it's a manufacturing unit, all right? So there would be those, what do you call, instruments, like the hammer, all the pulleys and everything, whatever is required for maybe take it as a mining industry or something. So who has taken it, for how many hours he has taken it? So say suppose the person who came here, he took it for 2 hours. Okay. So it would be mentioned there. So the next person, when the next person comes and walks in here, so he'll get to see this one, okay? And he knows that this is going to come in some time. So he'll wait. I mean, he'll just go back, come after 2 hours, and it will be there. Or he might be placing a request also that it should be delivered to them. Anything which is visually done, okay? This is all about the visual management. So this is what I would want to let you know. So as I told you, lean is all about the simple concepts. Okay, the simple things that we have been doing in our own house, okay, in our own home since our childhood. Say it a cleaning, say it something to do with the visual representation, say it for simplifying the process. It is just that it is just the next level of using it in terms of offices.
Excuse me,
Okay.
sir. Excuse me.
Yes, tell me please.
Sir, if we are using posters and checklists in our workplace, we can say it is Kanban.
If it is visually representing you something, sorry, I did not get your name. What's your name?
Sir, my name is Nishant.
Okay, Nishan. Yeah. So if it is visually signaling you something, okay, anything for that matter, and it is placed right in front of a board, you can say that the Kanban is at work. Okay. Sometimes what happens is, like if someone is from the financial industry, for the daily invoices, for the daily purchase orders that has been worked out by the AR team, that is the accounts receivable team, or for the accounts payable team, there would be a certain thing as to how many orders came, how many orders were processed, how many orders are in hold, how many orders had a problem with that. So It is just a visual representation of anything. So Nishan, by now you know that even the checklist, if it is placed in a place wherein everyone is able to see it, it works as a Kanban. Okay, it works as a Kanban.
Thank you,
All
sir.
right.
Thank you.
Yes, welcome, welcome. So now comes Kaizen. No, sorry. No.
Depend how much time we have left for this session.
I think it's 1 hour more that we have for the session. Yeah.
Sorry, I'm not getting your voice.
You're not getting my voice? Hello?
Yeah, it's not clear.
But I'm not sure. Hanan, is it you?
Yeah, I'm saying how much time is left for the session. I'm not getting your voice. It's not clear. It's not loud.
Close to 1 hour.
Yeah, close to 1 hour. Close to 1 hour.
Close to
Close
1
to
hour.
1 hour, Hanan. Yes, yes, Hanan.
Okay.
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 Okay. So let's look into the Kaizen thing, guys. Now, Kaizen is again a Japanese term. Okay, wherein Kai stands for change and Zen stands for good. So any good changes that you bring to your process, okay, would be considered under the Kaizen thing. Okay, this is very, very important because now actually I must take you to let me see if I can show you a little of the value stream mapping. So just a moment. Guys, this is an example of a value stream mapping. This is also something which comes under lean. It is nothing but you have you know about the process maps, right? This is just a what do you call a very highest version of the process maps, you can say. Okay, because process maps, you have simple process maps, you have swimlane process maps, and this is the highest version of this process maps, wherein these are the customer. If you just follow the cursor, they would be giving you the information flow. Okay, this is the information that they need something from you, and from here, let me see 1 second. So from this side, it will come here, and this will be the information flow. And from here, the product, you make sure that the product reaches the customer. And this becomes the material flow for you. Okay. And this is how you have to get this thing done. Now, what is happening here is it is a total calculation of how many people. See, 3 people are working here for my milling, 2 people are working for welding, 5 people are working for painting, 3 people are working for inspection, 1 people are working. So how much of a time? See, the cycle time CT is 2 minutes for all of it. CT is 2 minutes. Changeover time is 2 hours. 2 hours. Then batch, as to how much of a batch, how many, what is the batch that they are working on. This 200 that you see, all this VSM is all about many symbols, guys. Okay, it will have many symbols, but it is just a refined or a very good version of a process map. Now this I is showing you the inventory that this process has. So just before welding, you have this inventory. Just before painting, you have this inventory. Just before inspection, you have this one. And uptime shows as to how much of a time, if it is about 8 hours that they are working, excluding the breaks. Okay. So 30 minutes of lunch break and 15 minutes of the small breaks that they have. If you exclude that, how much of a time that they have in their hand, all right, to, to work on a certain process. So this is how it is going to help you. So if it is about the 74% thing, it is just going to help you out with the fact that 26% of the time of those 8 hours, this person is free. Okay, these two people, they are free 26% of the time. These 5 people also 26% of the time they are free. Uptime means how much time they are working, they are really working. So when you have this calculation, then you know that we might want to reduce 1 people from here and put it to a different process wherein the maybe the run uptime is 100%. So this is how you balance out the things, okay? And when you do that, when you do that, then what happens is you are bringing out a change, right? This is what the Kaizen thing was all about. When you are bringing out a change, you are representing it as something like this, okay? Something like this. And this is known as Kaizen burst for you. This is known as Kaizen burst. So wherever you are bringing out a change in the process for the good, there you can put something like this. If you notice here, this one, there is some kind of an improvement measure has been done. Here, if you see where I've made it, okay, where I marked it just. So that happens to be your Kaizen. So some kind of improvement measure was done. So this is why the process maps are important for you to understand as to where you should work on, or the place where you should be putting your corrections for the process. You should have a process map first, and this is about the value stream mapping. Actually, value stream mapping is something which can, I mean, for you to understand the complete value stream mapping and its calculations, it will take at least 8 hours. All right, 6 to 8 hours for sure. It is that big. So, but just to let you know, as to you should be familiarizing yourself with all the tools that you have in here. Okay, so yes, so that was about it. Let's see what is. Yeah, good that you guys are discussing also at the same time. Daniel, I can see Maya, Shiyok, Anita. All right. So this was about the value stream mapping. All right. So this is the Kaizen thing. The change for good. Any change that you bring in the process for the betterment of it would be represented like this, the one that I showed. And it is in essence known as Kaizen burst. So this is actually very, very useful. And this is how you are supposed to use it as well. So this is about the Kaizen, right? And if I may say, so Kaizen is just like, Six Sigma answer, but the normally in offices and all, you know, like Six Sigma black belt project will happen for a period of maybe 6 months. Okay, sometimes less than that, but normally at least for 6 months, a big project where you're thinking of solving maybe, you have no idea, like maybe million, $2 million. So it is big. It is big. All right. So for that, it might take 6 months. Now, this one, the Kaizen thing, it is also bringing out change, which is for the good of the process. Okay. But then again, this can be done within 3 days. So you can say whatever is happening here, the same thing is happening in here, but at a less amount of time. Yes, someone just called me. Hello.
Yeah, Divine, it's Anand here.
Yeah, Hanan. Tell me.
Sorry to interrupt, but I have to go to the hospital. I'll have to take my wife to the hospital. So I was just asking, is there any facility or is there any chance to have all the recordings of this session? Because I really have to go.
Hanan, actually, I'm very sorry, but I'm not the one to. I actually don't know about this, to be honest. So
Because
you
I'm texting to the IMC.
Yes.
Because you just said that na, call to the IMC. I've messaged, I texted them, but they're not replying.
Oh, okay.
I think there was a message in the chat which said that concentrate on the class, the notes and the recordings will be sent across, kind of a thing. So
Yeah, I also think I've seen that, Madhavan. Yes, yeah, I think you will get the recordings. I think you will get the recordings, but really not sure about that at this point of time.
Okay.
I understand. You just carry on, Hanan, because if it is to do with the hospitals, this can be done later as well for you. So I
Okay.
think you would be provided with the video, but for that you need to talk with the IMC. All right.
Okay, Divine. Thank you very much.
Okay. Okay. Take care, brother. Bye bye.
Thank you. Thank you.
All right. So
Excuse me, sir.
yes, Dashan.
Sir, Kaizen means we can use any process for the change of a process for good, right?
Yeah, change. See, the small changes. Okay, it is not that big change. So it is like the I think. Just give me a moment. I'll just tell you if I find that, I'll tell you right now. Just give me a second. See, the small changes, right? It would be known as Kaizen. But if there are big changes, like if this is a graph, okay, just take this example, okay? I'm just using maybe a different color. This kind of a change, you might want to call it as Kaizen, okay? But if there is a radical change, if it is a radical change like something has changed like this big, okay, you might want to call, I mean, you also have a different term for that, which is known as Kaikaku. So this is why I showed you this entire thing is just because Kaizen is for the small changes, Nishant. Okay. Anything, I mean, in your process itself, those small changes that you'd want to do, you'd be calling that as Kaizen thing for the whole of the process. Is that fine,
Thank you, sir.
Nishant?
Thank you.
Yeah, welcome. So this is about any ready. So thanks, Nishan, asked that question because you guys must know about this Kaikaku thing also. So Kaikaku is something which happens. I mean, if there is some big change, okay, some radical change coming in the process, okay. So just for the information, you must know about this, which is Kaikaku, and Kaizen also. You guys now know about what is Kaikaku thing. Okay, so what else we have? Let's just quickly check. Yes, you guys are aware of the standard operating procedures, right? So the one that is in every office would be having this standard operating procedures, which is
Yes.
just talking to you about the instructions. Yeah, yeah. So that very same thing, like any new hire comes, we would look into this SOPs, SOP, that is standard operating procedure, and we'll get to know as to how the work is happening. Okay, and this will just help them. All right, so not talking much about that SOP thing. Yeah. Okay. So the next thing that I'm going to talk to you about is just in time. What is just in time? So do you know this pizza delivery thing? All right. So what happens in a pizza delivery thing? They say that the moment you order, we are going to make it reach out to you. All right. So what happens is it is an GIT is essentially an inventory management system. Okay. If I have to just write a few words about this, I would write it as inventory management system. Okay. So this is about the inventory management system. So how it works is which aims at procuring raw materials and labor as and when requirement comes. Okay. Without investing in storing it. Shall I write the complete thing for you? Is an inventory management system which aims at procuring just which aims at procuring raw materials. If why I'm writing this for you guys, if you remember what I'm just writing here, never ever in your life you would want someone to explain you what is JIT and labor as and when as and when requirement comes without investing in storing it. Without investing in storing it. The best example for this would be kind of pizza deliveries, Domino's, or like what do you have that? Pizza Hut, all those things. So you order, they make. Okay, they are not keeping the pizza ready. They are not working in a push system. So you must understand that there are two things, which is push system and the pull system.
Best industrial example is Toyota.
Oh yes, of course. Lean actually started from Toyota. What's your name? Sorry, I did not get your name.
Suyog.
Yeah, Suyog, sorry. Lean actually started from Toyota itself, all right. Because before Toyota, how people used to think, we'll make more products, The quantity used to matter that time. If we make more products, that means more customers will come to us. That was the mindset before Toyota. And after Toyota happened, okay, the machine changed the world. After Toyota happened, it is people talking about the quality rather than quantity. So yes, of course, that is a very good thing that you said. So now again, just talking about the pull system. Pull system works like whenever the requirement comes. And you must also know about the push system here. What is push system? Push system is something which is just talking to you about what can be a good example for the push system? Okay, the medicines that are available in the medical store. So how come anyone knows that? Whenever you go to the medical store, most often you will find the common medicines at least, right? So it is dependent on. This forecasting is already done. Okay, that which medicine would be required at what point of time. So this forecasting is actually already done. So now what is happening is, now that you have done this, now that you have done the forecasting, so you're keeping the medicines ready. Okay, so that you go there and you get it. So this works in the push system. This works in for the like in the push system. Pull system is just like something that you would want to relate with a pizza delivery thing. Okay, pizza delivery thing. So this is how you would want to remember pull system. This is all that I like to talk about the just-in-time pull system. All right, there are a few more things that we need to cover up now. Cycle time done. Value stream mapping also I showed you later. Okay, guys. Now say suppose tomorrow you have taken this Lean Six Sigma. Of course you have taken it seriously, and that is why you were here. But tomorrow, if you happen to work as a consultant for Lean Six Sigma, and you go as a consultant, someone has hired you after conducting an interview and all, and then you're going to a project. What is that first thing that you would want to know about the process? Okay, before starting the process, before starting the work. Okay, what is that one thing that you should be knowing? That one thing is SciPoc. Without this, without having an understanding of the understanding of this particular cypher, you should not start your project. You know why? Because even if you start your project, you might find yourself stranded at the middle. Okay, I mean, thinking as to what would have gone wrong. Because first of all, you need to sit with the subject matter expert. Because see, the person who's working in the CEO's chair, he will be not, I mean, he of course he will be knowing, but not like the one who's I mean, dealing with the process day in and day out. Okay, that particular process, a big, I mean, a organization, irrespective of big and small, there would be many processes, right? Just like the functions that we have in HR, finance, marketing, customer service, all the processes would be having their sub processes as well. Correct. So for all the sub processes, there would be someone who would be working as a team lead or the manager. So for all those things, no, whenever you go for a certain project for a betterment of the process, what you have to do is, first of all, you need to sit with the subject matter expert, one who is considered to be the one responsible for that process, understand from him or her as to what is happening in the process. Then the next step for you would be to go ahead and document it. So if you're not documenting it, what is happening tomorrow is like you are just taking on the basis of his verbal comments, which might act against you at a later point of time. So what you have to do is you have to just speak with the person, understand as to how the process is running, document it, get it signed from the person who's responsible, the person who actually hired you. Say that this is what I understand as your current process is. Okay. Once you understand that, then finally you start with your improvement measures. Improvement measures in the sense you start defining and measuring and analyzing, improving and controlling. So all those things are going to just follow you. All right. So how do you, now that you have understood the process, but how have you understood the process? Here comes the SIPOC. Here what is happening is S stands for suppliers. Suppliers. Okay. Then I stands for inputs. P stands for process. O stands for output. Sorry. And C stands for customer. This is the mother of, I mean, how do I say it? Like before you start your improvement thing or anything to do with the Lean Six Sigma, you must be very much sure of what the process is, where from it is getting started. Suppose take an example of purchasing a car. Okay, just take an example of purchasing a car. So what are the things that we should be wary of? What are the things that you should be knowing? Okay, in terms of suppliers, I mean, this is just an example. It can be far more complicated than the example that I'm showing you now. Okay, so the dealers, the individuals, it can be also, sometimes people will also take it as scopus. Scopus is nothing but you start from here and then come to S, COPIS. So let's get back to that main thing. So suppliers are the dealers or the individuals. Inputs are the like what inputs you get there: models, specification, then comes the price, the availability. Okay. Then comes the process, which is this is about the process of purchasing a car. Sorry, in the hurry, I actually did not. This is the process of purchasing a car. Okay. Here, what is happening is purchasing a car. I'm just writing this thing. Okay, there is no space much. So, and then comes like output is the car, the paperwork that has to be done, the service contract, the delivery date. And believe me, there are many examples that you can find in Google. So please go ahead and have a better understanding of SIPOC. And without knowing what the SIPOC is, please do not start any of your consulting. All right, because after a certain time, you might find yourself like stranded, and the blame will come on you itself. Okay, no one will take the blame. As much as it is tough to get to where you have to reach as a Lean Six Sigma guy, all right, but later if something wrong happens, then the entire thing is going to come to you itself. So be very sure of what I just told you right now. Determine car option review. So below it will be determine car option. Then you have review, specification, and test drive. I'm just writing spec and test drive. Then you have negotiate pricing for the purchasing a car. Okay. Negotiate pricing and delivery date, of course. Then comes sign paperwork. Sorry for the handwriting, guys, but I guess when I'm talking, you will relate to it. Sign paperwork. And then finally, collecting a car. This is how you, I mean, it has to be much more detailed from what I have shown you. The process should be very clear in your head, okay, what is happening. So if there comes a problem, you will be rightly placed to solve it. And this is how you should approach your Lean Six Sigma project. Okay, so there's another thing that I would want to bring your notice to. Just give me a second. Guys, do you know about critical to quality?
Nope.
Okay.
Debayan, I have a question here. Like the SIPOC which we are talking on, is it the same SIPOC which we are having in the PMP also?
Yeah,
is
yeah,
the
yeah.
both same?
Yes. It's the same thing. Sorry, I did not get your name.
Krishna.
Okay, Krishna. Yeah, it is the same thing. SIPOC is something which you be using in all the processes. Without a doubt, you can say that this is the same thing that could be used there. It just goes hand in hand. I'll tell you. I mean, the Six Sigma and the project management things. Okay.
Okay.
And
So which one will have a more impact on the practical environment when you coming to project life?
And in comparison with Six Sigma and project management?
Yes.
I, being a Lean Six Sigma guy, I would say Lean Six Sigma. See, honestly, to be very honest with you, what happens in the project management? It is just that, I mean, whichever project you are, a part of as a project manager, it is your responsibility to make the project good, all right? By taking into consideration the problems that might come while you are making the conducting the project, all right? Or if it is an ongoing project, you do not want any problems to appear. But how will you solve that? For solving that, it is not, you have to use this lean things only. The leans, the hypothesis testings, measurement system analysis, the capacity planning, the sustaining, you need to use the control charts. So for all the things that you're doing in the project management, you have to use this lean tools apart from the statistical calculations. Okay, you have to play with the data. So project management, you would be just planning as to by when a project, I mean, it is of course big. In project management also, there are so many things which when, if we, I suppose you are a project manager, Krishna?
Yeah, I'm a project manager. Yes.
Okay, okay. So you, once you see the complete curriculum of the Lean Six Sigma, no? Maybe after the training, I would just request you to just maybe open it in Google itself. So you will see a lot of it, a lot of similarity between the work that you're doing and the one that you have in Six Sigma. Yes, the refined version of it is something which you will find in Six Sigma is because it is not only about the lean, and this is something that we are just doing for the yellow belt. The gradual progress in the Six Sigma would make you introduced to the data science, okay, which is talking to you about the hypothesis testings. So how would you, you have two samples. How would you compare it? First, before you compare the two samples, you have to check whether they have equal variances or not. Say suppose it is not two, you have three samples now. So which test are you going to use? You are now no more going to use a two sample t-test. You would be then using a ANOVA, which is analysis of variance. And then if suppose you want to find out the equation, like there's a height and there is a weight, okay? You need to find out an equation wherein it says, you must be knowing it. I'm just talking to you about the correlation and the simple linear regression. So how much of
Yeah,
a
got it.
height? Yeah, how much of a height depends on how much of a weight, or how much of a weight depends on how much of a height, all those equations. And if you have more excess, then you go for the multi regression analysis. And if it is, see, what is linear? Linear means straight. Anything which is not straight, it can be quadratic, it can be cubic. So the equation can be linear, the equation can be quadratic, the equation can be cubic. The cubic equation is of course more complex. Quadratic is a little less complex than the cubic one, and the linear one is the most simple. Linear is nothing but a straight one. And once you go to regression, you have to understand about the residual analysis also, which is again another thing, a subject of its own. But let's not talk about that thing. There are a few things that we need to complete before, when we just have half an hour left with this. So I'll just quickly show you a CTQ thing, okay? I'm not.
Excuse me, sir.
Yes, yes. Yeah, who's
Sir,
this?
what is copies?
What is?
Copies.
Coopis is, brother, Coopis is nothing but, you see, this is starting from supplier, input, process, output, and customer, right? So for Coopis, you'll start with the customer. Then you'll come to output, then process, then input, and S. Just the other way of looking at it.
Okay, done. Thank you.
Okay, yeah, sure. Okay, guys, now what is the CTQ thing? I'll quickly try to show you a good example from CTQ. What could be a simple example? Guys, if we can just look at this one. This is an example of a CTQ3. I need my paycheck. Okay, it is first of all divided into three parts, okay? Customer need, I mean, this one, the one that you have here. Then these are called as drivers. So let me see if I find a better example. Just give me a. See, first comes the need, then the drivers, and then the requirements. If you can see it, okay. So Okay, this might help you in understanding. Okay, first comes the need, then comes the driver, then comes the CTQ metric. So this is about the need, then the driver, which is about talking about the friendliness, the cycle time and turnaround time, and the attentiveness, and CTQ metric. I mean, this is okay, but you get the idea, right? CTQ is nothing but the critical to quality, okay, which is just dividing it into three zones. What is the need? And then what are the drivers for achieving that? And finally, the metric, okay, which would be mostly talking to you about the time or the percentage. All right. So this is how you would want to remember this one. So CTQ would be having specification or tolerance limits. Specification limits and tolerance limit, I'll just quickly show you. Maybe that is very important. Okay, this is CTQ3, and I would want you to just pay maybe just after the class, just come here for a better understanding. CTQ means critical to quality. Okay. Now, just a second, guys. I'm not sure what is happening here. I'll use this only, okay? Normally, uh, normally in a process, it would be, this is your process, right? This is the shape of your process. This is the mean, and I showed you what is the standard deviation, how we calculate it. I mean, the software will do it for you, but you must know as to what is happening in there. Then comes, there is one thing that you must know, that is the specification limit. The specification limit, this one is USL and this is LSL. What is this? Sorry.
Upper control limit, lower control limit.
No, this is specification limit. Control limit is something else. I'll just show you. Okay, just take it as LSL, okay? That is specification limit. Someone just said control limit, right? So I'll tell you, specification limit is something which is set by the customer. The customer wants the process in between USL and LSL. And what you mean by tolerance is equal to USL minus LSL. Okay, this is going to give you the tolerance. Now, this is something which is very much, I mean, for the process capability and all, we would be using this. So if your process is like this, okay, say suppose if your process is, I'm using the same color, okay, if your process is well inside the specification limit, this is USL, this is LSL. If the process is well inside the control limit, that means it is good. But your process might go wrong also, right? So like the process can go wrong from this side. I mean, your process is like that. That means it is well below the upper control limit, upper specification limit, but it is having a problem in the specification. I mean, lower specification limit. Otherwise, you might see a process like this, wherein your process is well inside the lower specification limit, but it is more than the upper specification limit. And this is what you should know about the specification limits, okay? Because if your process is not inside, if the customer wants you to make a shaft, and if the customer, where is that now? Okay, if the customer wants you to make a shaft, okay, and he wants to make it he wants you to make it between 8 millimeter and 10 millimeter. Okay, then this USL thing becomes 8 millimeter and this 8 becomes the LSL. Okay, and when it comes to the control, remember specification limit will be only from the customer side. Okay, it will be always from the customer side, and the upper control limit and the lower control limit, if we have to talk about that particular thing, it is something that our process or our managers, they will decide on it. Like specification limit is okay, that much here it is okay, but our process itself is very stringent. Our control limit is, our lower control limit is this one, our upper control limit is this one. So it is just like making the process more robust, okay, by making it more strict so that we do not lose track. This is the difference between the USL and LSL and LCL and UCL. This is upper specification limit, which is set by the customer, and LCL is lower control limit. And this one is upper control limit. Okay, and you must know that. And there is a saying that there is an equation which is just on a higher study, but I'm just sharing with you. Voice of process by voice of customer. Okay, if it is 1.33, it is considered to be good, and this is in terms of CPK. So the higher studies will take you to a better understanding of what the CPK is all about. But it is just that you must start knowing about all these things now. So I told you when we started the course that we have Z score, we have CPK, we have PPK, we have CP, we have PP. There are so many things, all right? So this is how you should start finding about things, okay? Okay, this is about this, and what else do I need to show you? Guys, do you have any idea about the FMEA, failure mode effect and analysis? Anyone knows about FMEA?
No.
No, sir.
Okay. It is actually one of my favorite things, but I don't think we have enough time, but let's see how much we can cover, okay?
Is that the analysis of possible failure chances?
Oh, yes, of course. Like
Okay.
that, you have three things, okay, Anya? So first, let's read this. Failure mode and effect analysis is a structured approach to discovering potential failures that may exist within the design of a product or process. Failure modes are the ways in which a process can fail. Effects are the ways that these failures can lead to waste, defects, or harmful outcomes for the customer. We'll just look into one of the examples. I wish I could enlarge it. Yes, great. Okay, now, before we get in there, just follow along, okay? There are three things that you need to be knowing. There are three things that you should be knowing about the FMEA. First one is severity, occurrence. Second thing is occurrence. And the third thing is detection. What happens is, okay, first of all, let me write, okay? Then it becomes easy for you to understand. 10, And then occurrence also you have between 1 to 10. And then you have detection between 1 to 10. Now what is happening here, guys, is you, for any of the process, all right, it, just give me a second, guys. See, no, I'm not finding the real notes for you, okay? But anyways, risk priority number. See, how severe, I mean, see, suppose you started your car in the morning and you're going towards your office, all right? What happens is, say, suppose the fuel meter, it shows you that you have enough of fuel, okay? So you now know that you will easily reach office and there is going to be no problem. What happens there is this particular thing, the car, the fuel gauge, I mean the fuel meter, it say suppose it has gone faulty, it is not showing you the correct thing. What happens is you are left stranded in the middle of the road on your way to office in the morning. So what is happening here is it is I mean, now that you know that this is a problem, this is a problem that has happened with you. Where would you want to put this in a severity number from 1 to 10? Okay, all the things that you see here, severity, occurrence and detection, it is rated in between 1 to 10, 1 being the least severe, 10 being the highest severe. Suppose the brakes went fail on the cars, that you might want to consider as the most severe thing, correct? So like that, you have to divide it in between 1 to 10. Anything which is less severe, you might want to put it in a one category, and anything which is more severe, you might want to put it in 10th category. Similarly, for what you see here in the occurrence, how likely that problem is going to occur. If it is very less likely, then you might want to put it in 1. All right. If it is something which might happen, if it might happen, like I mean, there are high chances of you having that problem, then you might want to put it in the 10th category. Okay. And then comes the detection, which is like how, I mean, is your process automated? Will it be able to detect the problem if it may occur? So in that scenario, what is happening is you might want to put it in the 1 category. And if your process is actually not capable of identifying or detecting the problem, then you might want to put it in the 10th category. So risk, what happens is all the 3 things are calculated by multiplying. So severity into occurrence into detection. What is happening here is this is how you're going to calculate. And now that you know that it would be severity severity would be in between 1 to 10, occurrence would be between 1 to 10, and detection also between 1 to 10. So you know that the risk priority number would be somewhere in between 1 to 1000. Correct? 1 into 1 into 1 makes it 1, and 10 into 10 into 10 makes it 1000. So severity into occurrence into detection is going to give you your RPN number, which is RPN, which is risk priority number, this one. And this is how you would want to identify things. There are a few things. This is actually finding one. So for FMEA, there are 6 things that I would want you to know, okay? And the first thing is identify key process steps. Okay, this is the first thing that you're going to do. Second comes identify failure modes. The third thing that you're going to do is identify failure effects. This will fall under severity. Then comes the fourth one, which is identify causes. This will fall under occurrences. Then comes the fifth one, which will be identify controls, which would fall under detection. Now you're able to relate to it slowly, right? Identify failure effects, how severe it is going to be. Identify causes, what are the chances of it occurring? Is it less likely or is it highly there are high chances of it occurring. All right, then comes identify the controls, whether your process is automated enough to identify the failures. Okay, that is one thing. Now the sixth thing is calculate the risk priority number. So you're now going to calculate the risk priority number. You now know how to do it. You have to first rate it in between 1 to 10, and then finally calculate risk priority number by multiplying severity into occurrence into detection. Okay. Now the next step is going to be you get so many results, right? Now you have to prioritize by RPN. Which RPN number is the highest? By that, you're going to prioritize the higher, just typing it out for you. Okay, higher RPN first, and then comes in the 8, determine action plan. And then comes the 9, which is recalculate RPN. And to be honest, this FMEA is a dynamic document. Okay, why I called it dynamic is just because it is a living document. Any moment a failure can happen. And for everything, if you record it well, if some failure has happened 2 years back, and if you have recorded it well, if you have calculated the RPN number and you have taken the action on it, then you know that in future, in case of a problem, you exactly know what has to be done. That is only when you haven't solved it. But if imagine that you have already solved the problem 2 years back, then that problem is never going to reappear, correct? And this is why FMEA is one such thing wherein you do not need any lean thinking and the hypothesis testings and all. It just comes to you, all right? And it is very good one. It is something that you should be using a lot.
Excuse
Now,
me, sir.
yes, tell me, Nishan.
Can you give one more example, please?
Yes, we haven't gone to the example itself. So let's look into this one, okay? Wherein it is talking to you about the ATM pin authentication and dispense cash. Now, if you look into it, this is the severity, okay? This is the severity. Wait a minute. You can see, right, on top, you have severity, you have occurrence here, and you have detection here somewhere, okay? This is severity. This row, if you follow on top, this is about severity. This is about occurrence, and this is about detection. Just see. The potential failure mode that you have here is unauthorized access. Potential failure effect is unauthorized cash withdrawal and very dissatisfied customer. So what is the severity issue here? Unauthorized access. So you can imagine. So the severity issue is 8. What are the likely chances of it occurring? 3. Okay. How easily you can detect it? Okay, detect a detection of the failure mode of its cause. How your system is able to detect this. 3. This is also rated as 3. So similarly for all the other things, I would just want you guys to No worries, but if you, I mean, no worries about, don't worry about this time thing. Anyways, we have just 12 minutes, but I would want you to just read the other things. Here, the authentication failure, customer is annoyed, potential failure effect. And this is again rated in terms of the severity, this is occurrence, and this is detection. This is again severity, this is for dispense cash. This is for ATM pin authentication. These are two different things. For dispense cash, again, there is a problem here, severity, occurrence, and detection. So I've taken it directly from Google, okay? So you can just come here and see it again for us to know as to what it is all about. And then how you calculate, I mean, which is the highest one? I mean, anything which is more than 100 in a real scenario, guys, anything which is more than 100 is considered to be a big problem. At the same time, as I told you, you have to always prioritize. Prioritize by RPN. The highest RPN number is something that you should be dealing with at first place. Got it? So this is about the RPN thing. So now that you know that this is the major problem, cash not disbursed, okay, the rating system. And you must be thinking as to who rates this, right? You as a part of the company or the managers or the management, the senior management, they'll sit for the discussion. They'll make you also a part of it as a consultant. And you people only will rate it. It is not something that these numbers you'll get it somewhere. It is something that depending on the process that you are a part of or the organization that you're working for, you people will decide by yourself as to what numbers you want to give in terms of in between 1 to 10 for any severity, for any possible severity, any possible occurrence, any possible detection, the detection capability, the occurring chances, the chance of it occurring, and the severity issue. Like as I told you, like the fuel meter showing you a different result or the brakes getting failed. So I just want you to relate with it. As long as you are not relating yourself with the main thing, it might be a problem. So actually we don't have, but remember one thing, SIPOC is what you start your project with, okay? If for anything, you must be knowing and having a clear idea about what SIPOC is all about. So if you are very good with understanding of the process, then only you should go for it. So Kanban we talked. Okay, just a quick talk about this one, the Zidoka thing, okay?
Hello, Debayan.
Yes. Yes,
This
Remo?
is Remo again. Yeah, I just
Yeah.
have a question about the rating of the severity, occurrence, and detection. Can we modify the rating? Like, for example, for the severity, we'll just use 1, 2, 3. Like the severity, we'll categorize it as low, medium, and high. 1, 2, 3.
Okay, I got your question, Remo. So normally what is happening here is in FMEA, it is a set rule that you have to calculate or designate a particular problem in between 1 to 10. Okay, so it can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And depending on this, and the same goes out for the occurrence and detection as well. So once you have these things, then you have to finally go for the RPN, which is just nothing but the multiplication of severity into occurrence into detection.
Yeah,
What
no,
if,
sorry. My question is, can we just use 1 to 3 instead of 1 to 4?
No. For this,
No,
for
it should be 1
so
to 4.
yeah. Think for a bigger organization thing. So there would be many problems like that, Remo. So if
Because
it was about
just to share with you, currently we're using 1, 2, 3 to easily identify the severity of the incident. Like this has a reputational risk, so we can categorize it easily as high risk. So we can use number 3.
No, I got your point, Remo.
For guidance.
Not a problem, Remo. I understood your thing. It depends on the organization that you're working for as well. Okay. In the larger organization or in the mid-size organization also, normally what what is happening, Remo, is what I have seen. Now, what you are saying is 1, 2, 3, of course. So if you have 1, 2, 3, you only have three options, right, Remo? Either
Yes.
it is low, medium, or high.
Hi.
Correct?
Yes.
You
Yes.
only have two options. Now, if you are bifurcating the same thing into 10 different things, now you would be having a better sense of, I mean, if it is a minor risk, if it is a major risk. So anything which is like a major thing, it would be more than 6 or 7 or 8, kind of like that. Of course, the way you said, it can be done. So it is just a personal choice. Okay, if you want to have it done like that, you can do it. But I have to talk to you about like how the FMEA has been followed. I mean, across all the body of knowledges, right? Like ISSE or ASQ. So if I have to follow that one, Remo, in there they have all, I mean, almost always explain the severity, occurrence, and detection to be counted in between 1 to 10. Okay.
Okay. Got it.
Okay. All right. All right.
Thank you.
Yeah, most welcome. Most welcome. So, what else we have? Okay, poker yoke is something that I would want to quickly show. Maybe we are just having 5 minutes left. So, poker yoke is something which is, what do I say, mistake proofing, okay? It is again another Japanese term, okay? So what are the examples of a poker yoke? Just have a look at this. So let me give you a better example. I mean, just have a look at this and I'm giving you an example. Like the pen drive, which is going to fit in my laptop, this same pen drive is going to fit in Remo's laptop also. You understand? So it is made in such a way that it doesn't have any mistakes in terms of fitting in my laptop and Remo's laptop. So that is how you should start identifying what the poker yoke is. It is just a thing which is normally used in the improve phase. Okay, DMAIC. So in the improve phase, you would be using this poker yoke thing. It's a C, guys. I don't know. It's a C. Okay, this Lean Six Sigma is a big C. So when, which one? There will be many things will be coming your way. Again, there's one thing I would want to tell you. Not sure when we'll meet again. Yes, of course, if there is any possibility of connection, we will connect. And this is a book that I would want you to read, okay? The Machine That Changed the World, okay? This is by James Womack, Daniel Jones, and Daniel Roos. It was published in 1991. This will talk to you about the entire lean thing, lean measures that were taken for the Toyota production system. Okay, this is one book that I recommend, and there is another thing that I want to recommend. The name of the book, I'm sorry, I'm not remembering, but it was, I guess, The Goal. It was for the total productive maintenance. Okay, it is overall, it is about the machineries. Okay, overall equipment effectiveness. Okay, if you get this book also, please go through this two book. I'm a little worried about if the name is Goal itself, but if it is published in 1986, that is the one.
Sir,
Okay,
it's
so,
right. The name is right. The Goal.
okay. So yeah, so this is the one. So it was published in 1986, and if possible, guys, please read through that. And this is the closure of whatever we went through. I hope you guys liked it.
Yes, sir.
Okay.
Thank you.
Fatima, yeah, thank you so much. I just got a question. Yes, I'm there on LinkedIn. So of course we can get in touch. But apart from that also, it is just that first of all, you guys need to know, Fatima, this is especially to you. you have to first know the tools that we use. First, you need to go through these green belts and the black belts to understand what is the hypothesis testings and all those things. So once you get to know all the minor things, that is when you can start using it collectively for the wholesome purpose of using it in any department that you'd want to. All right. Okay, guys. Thank you so much. Thank you so much, everyone. It was nice having you all for the last 5 hours. And I wish
Thank
you
you,
a
sir.
great weekend. Yeah, thank you so much. Thank you so much, everyone. Thank you so much, everyone.
Thank you, sir. Thank you.
Debaya.
Good night.
Thank you, Nisha.
Thank you, sir. Thank you so much.
Thank you.
Wonderful session. Thank you very
Nice
much, sir.
session, sir.
Thank you,
Wonderful.
Devan. Thank you, Devan.
Got to know many things.
Thank you. Thank you so much, guys.
Thank you, Devan.
This is pure happiness. This is pure bliss. Thank you so much, guys.
Thank you, Devan.
Thank you. Thank you, guys.
Thank you very much.
Thank you. Thank you, sir. Thank you, everyone.
Thank
Take
you,
care,
Devan.
guys.